Hello and welcome to ZaranTech. In today's fast-paced business environment, having robust business intelligence tools is essential for making informed decisions. Today, we're diving into the fundamentals of SAP BO 4.2. Well, it's a comprehensive suite of business intelligence tools that empower organizations to extract insights from their data, helping them make informed decisions and drive business growth. Businesses leveraging SAP BO 4.2 make decisions 5 times faster. As data doubles biennially, harnessing it is vital for competitiveness. Mastering SAP BO 4.2 unlocks organizational data potential. Insights revolutionize work across finance, marketing, operations, and beyond, driving business success. In this course, we'll cover everything you need to know to get started with SAP BO 4.2. From navigating the user interface to creating dynamic reports and dashboards, we've got you covered. Plus, we'll explore advanced features and best practices to help you maximize the value of your data. Before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now let us look at the agenda. Agenda 1. Overview of SAP BO 4.2. 2. Introduction to data warehousing. 3. SAP BW and source systems, data modeling. 4. Steps to load data into InfoCube. 5. Introduction to Business Explorer. Let's dive in.
So when we are talking about OLTP systems, it can be of two areas. One, it can be an SAP source, because as your business object is a product from SAP, so we will also consider SAP source here. So one is an SAP source, that is SAP ECC system, Enterprise Central Component, and the other one is non-SAP sources. So when we are talking about non-SAP sources, it can be, it can be anything. It can be your Oracle database, or it can be your DB2, or it can be your Sybase. It can be anything. Okay. Now, usually what we do is whatever the transactions comes into this OLTP system, if you are an ETL developer or if you have worked in a data warehousing technologies, you'll move the data from your OLTP system to your data warehouse. In order to move the data from OLTP system to your data warehouse, ETL is the process which we are going to use. Okay, ETL is the process which we are going to use. Now, where your business objects comes into picture in this scenario. Okay, so once you move the data from your OLTP systems, or once you load the data from your OLTP system into your data warehouse, in your data warehouse you will be doing 3 main responsibilities. You are allowed to do 3 main responsibilities. One is you might be working with the modeling part and the ETL process, and finally the reporting part. When we are talking about reporting, there can be many reporting tools, because one of the main reasons to maintain a warehouse system by any organization is to have a quick look at what is going at an organization level or at different areas, from summary to the least minute details. So we have a lot of companies in the market that delivers different reporting solutions. Okay, so we have many players, reporting players in the market. For example, we have Tableau, we have ClickView, and we have some Cognos. There are many reporting tools in the market. But if we have to choose enterprise level reporting solution with excellent flexibility and multiple reporting options, then the right choice is your SAP BO, because it is one of the main competitor in the market. When it comes to reporting tool, your SAP BO is one of the main competitor in the market. So here your BO comes into picture. So after your data warehousing, say this is your reporting component, and this reporting component I'll name it as BO. So before understanding this business objects, its reporting platform was initially built by a company called Business Objects. Earlier it doesn't belong to an SAP, but it was initially built by a company called Business Object. Later on it got acquired by SAP in the year somewhere around 2007-2008. So after acquisition of business objects by SAP, then SAP named this component as SAP BO. The version at that point of time, it is SAP BO 3.x. So SAP named this version as BO 3.x. And now if you notice, now it is not BO 3.x. Rather, the latest version is, it is called as SAP BI Business Intelligence, and the version is 4.2. This is the version, the current version which we are using now. So SAP Business Objects BI platform is a flexible, scalable and reliable solution for delivering powerful interactive reports to end users via any web applications. And your business objects is an integrated suite for reporting, analysis, information delivery. So the BI platform provides a solution for increasing end user productivity and reducing administrative efforts. So when it comes to business objects, there are so many changes happen from the previous version to the newer version. The newer version is SAP BI 4.2. I think so few of the participants, they have worked in business objects in the older versions. Maybe they might have worked in BO 3.x or some XIR2 or some other older versions. Okay. Now let us see the main components of this SAP BIBO platform. So when we are talking about the main components of SAP BIBO platform, these are the main components we have. First we have a central management console. Usually we call it as CMC. CMC stands for Central Management Console. Then the other component we have is Server Intelligence Agent. The second one is Server Intelligence Agent. And the third one, usually we call it as CCM, or it's called as Central Configuration Manager. And the next one we have is CMS, which stands for Central Management Servers. And then we have a semantic layer. Then after semantic layer, then we'll have all the client tools. Okay, so these are the main components of your SAP BOBI platform. And when it comes to architecture, in your older version, maybe in SAP BO 3.x, it's a pi-tier architecture. But if you see the newer version, in newer version, it's not a pi-tier architecture. Rather, it's a 6-tier architecture, which comprises of client tier, web tier, management tier, storage tier, processing tier, and data tier. These are the 6-tier architecture. So when we are talking about SAP BI BO 4.2, it's a 6-tier architecture. It's no longer a pi-tier architecture as mentioned in BO 3.x. Okay, so in this session we are not going to discuss in detail about the tiers. Rather, we will be seeing what are the different components available in business objects. Okay, we'll be seeing the different components available in business objects, and also I will show you the overview of that component by opening my remote desktop as well. Okay, so first let us start with BI Launchpad. This is one of the components we have. Of course, in 3.x we have something called Info View, but in SAP BI 4.2 they have came up with the BI Launchpad. So your BI Launchpad, it's a central starting point for end users. So let me show you the BI Launchpad, how the look and feel of your BI Launchpad is. So this is your remote desktop, business intelligence. I think so here like we don't have access to the BI Launchpad. Okay, anyway, it's a central starting point for end user, and it lets the authorized end users to open, display and edit the documents stored in the system. And the main page of your Launchpad is divided into 4 areas generally, and these 4 areas gives you direct access to the documents you displayed and executed. So one of the main components of your SAP BOBI is your BI Launchpad. As of now, I couldn't able to show you this BI Launchpad, but later on in the coming sessions, definitely like we are going to work on this. And the next component we have is IDT. It's nothing but your information design tool. So people who have already worked in the previous versions of business objects, you might have aware of Universe design tool. There's something called Designer. So later on in 3.x, in SAP BO 3.x, they used to call it as Universe Designer. But now, along with Universe Designer, with SAP BI 4.x, they came up with a new interface called as IDT, Information Design Tool, which is used to create universes. And when we are talking about IDT, it has the same general purpose of UDT, means Universe Designer. But the only thing is the structure of IDT is much better suited to a professional development environment. So let me check for IDT. So this is the IDT. So people who have already worked in Universe Design Tool, this is the one which you have worked in the older versions. But now for all the new projects, we were using Information Design Tool. The complete look and feel is different compared to your UDT, which is your older version. So using this IDT, what you can do is you can create universes. So when we are talking about universe, a few participants might have aware of this universe. A universe is nothing but it's an you can say it's an organized collection of metadata objects that enables business users to analyze and report on corporate data with non-technical languages. So if at all I want to create a universe, first what I need to do, I need to create a project. So there in UDT, if at all you have already worked in UDT, usually you'll go for a universe name and you'll give the data provider connections, ODBC connection or whatever it is. So by using this project, the local project, you can design a universe. As a developer, you can design a universe. But before designing a universe, we have different connections here. If you have worked with UDT in the older version, you have connections like relational, OLAP. So whatever the connections you have, almost we have the same connections, but the look and feel is entirely different. And there you have, when you're creating a connections, there you may have different kinds of connections, like you may have a secured connection or you may have a personal connection, shared and so on. But here no, like if at all I want to connect to a relational connection. So when I'm talking about a relational connection, it can be my SAP source or it can be a non-SAP source, as I have shown you in the diagram. So if at all I'm talking about relational connection, it can see here. You can see it can be a connection from ECC or it can be from a non-SAP source. So to define a connection from relational connection, you can connect by giving your resource name. Resource name is nothing but it's just like your test connection. It's like your name of the connection. And these are the different middlewares you can choose from. So when you're working with SAP Business Objects and when you try to design a universe, okay, or a semantic layer, so you can use any of these middleware drivers. So these are the different middleware drivers. So see, we have an SAP source. When it comes to SAP source, we have SAP ERP, ERP6, even HANA database. Okay, when I'm talking about a relational database, even you can have a connection to your HANA database as well. By default, along with this installation, we'll get a MS Access data source. That is the default installation. So you can select the required driver in order to create a semantic layer, that is the universe. So what you need to do is you need to select your driver, go to next, and provide the username password. In this case, as I told you, it's MS Access is a default data source. So we no need to provide any username password. All you need to select is a data source name. Of course, here the data source name is MS Access only. Okay, let me try with a different username. Okay, so I think so there's some problem with the connection. Anyway, like by selecting your ODBC drivers, what you can do is you can connect to your either to a relational database or to an OLAP connection. When we are talking about OLAP connection, we can even connect to an SAP BW system, or you can even connect to different OLAP databases. So OLAP connection is particularly for BW system. And in data foundation, this is where you will create joins and you will insert tables and you will perform all the, if at all you have any issues with loops and all these things. So in data foundation, you will be doing all these things. But people who have already worked in business objects, in UDT, I think so, you will have a different interface, not like this, wherein how you'll insert your tables, perform joins, and you'll mention some cardinalities and all. The same things we can do here in data foundation. Then in business layer, this is where you'll design a query for your universe. This business layer option is not available in your older version. So this is about a brief overview of IDT, Information Design Tool. So your Information Design Tool is nothing but it is used to create a universe. And if at all we want to create a universe, usually what we do is we will define the parameters, then we will insert tables, then we make joins, then we resolve the join problems, so on. Then finally we'll create classes and objects. So in the business layer, we will create classes and objects. This is an overview of IDT. This is one of the component again in business objects. Now going to the next component. Then we have reporting and analysis components. So when it comes to reporting and analysis components, your business objects has more than one reporting component. So when it comes to reporting, your BO has more than one reporting component. These are the different reporting components we have. Whereby rich client, this is nothing but it is similar to your desktop intelligence in your older version. If at all you might have worked in older version, it's similar to your desktop intelligence. Now it is whereby rich client. Then we have another reporting component called as whereby. So let us see all these things in overview of all these things in the coming coming few minutes. So one is whereby rich client, other one is web intelligence, and the next one is crystal reports. The next one is crystal reports. So we have three different reporting tools. First, let us start with web intelligence. When we are talking about web intelligence, it provides business users an easy to use, interactive and flexible user interface for building and analyzing reports on corporate data, either through web and through secured intranets as well as extranets. So as of now, whereby I can't show you because the BI Launchpad, I'm unable to open the BI Launchpad. What I can show you is I can show you a whereby rich client. Your whereby rich client is similar to your desktop intelligence in your older version. This is how your whereby rich client will look like. See, we have a shortcut icon here. Now whatever the universe you created by using IDT, by connecting to this universe as a data source, what we'll do is we can create a report. So your universe is one of the data providers. So this is your whereby rich client. Your whereby looks like same, but the only thing is what you do is you can access your whereby through a browser, but not through a window. And in your whereby rich client, these are the different data sources wherein you can connect to any of these data sources and you can create your reports. So what is the first data source we have here? Universe is the first data source. Already we know a universe is nothing but it's a semantic layer wherein you try to create a schema. Okay. So apart from universe, we can even create a report by selecting a spreadsheet or Excel sheet as a data source. And if you are a person from SAP BW background, then in SAP BW we have something called Business Explorer, or usually in shortcut they call it as BEX. So whatever the queries they created in Business Explorer, even the queries can be accessed from your whereby rich client and you can create a reports. Then the fourth one we have is analysis view. When we are talking about analysis view, this analysis view is from your SAP HANA information model, because in SAP HANA information model, if at all we want to connect to SAP HANA system, then we can access analysis view, because in the IDT part, we have seen that as a relational connection, we can even connect to SAP HANA database. So if at all you want to use your SAP HANA database, then you can even select this analysis view. Then the next option we have is a text. If at all you want to select a text file as a data source, in that case you can go for text. Then web service. So these are the different data sources wherein you can choose in order to create your reports from WebI Rich Client. And your WebI Rich Client, it works offline as well. It has even the offline reporting capabilities. It has a powerful ad hoc reporting capabilities as well. So this is one of the components, reporting components, that is web intelligence. Then we have crystal reports, because as I told you, your WebI and WebI Rich Client both look same. Okay, there is not much difference. But the only thing is, as of now, I can't show you a web intelligence because my BA Launchpad has not configured yet. And we have another reporting tool called as crystal reports. So when we are talking about crystal reports, it's a pre-built reports wherein you can create a pre-built reports from static to a dynamic layout. And also you can even perform an operational reports by using crystal reports. So let us see an overview of this crystal reports. In crystal reports, they have introduced two different versions. One is crystal reports 2013 and the other one is crystal reports for enterprise. So whatever you see here, it is crystal reports for enterprise. Okay, and also we have crystal reports 2013. The main reason SAP came up with crystal report for enterprise is your enterprise crystal reports enterprise 4 is more suitable with your HANA database. So that is the reason, along with crystal reports 2013, SAP has also released crystal reports for enterprise 4. This is your crystal reports overview, crystal reports for enterprise 4. And as I told you, like you can even perform operational reporting as well as you can pre-build reports from static to dynamic layout. So if at all in crystal reports enterprise 4, if at all you want to again create a report, what you need to do is you need to access your data source. See, from data source. Now what are the data sources available here? We have different data sources available here. Okay, I think so even crystal reports has not yet configured till now. No, it's not yet configured. Actually, the server which I am using is a HANA server, so they have not yet configured crystal reports. Anyway, like we will be seeing in the introduction session, we have again an introduction session as well. As of now, we are seeing the demo session, and whatever the server we are using is a demo server. Now the next component what we have is SAP BO Explorer. So when we are talking about SAP BO Explorer, so usually it's used for search option and to explore the data. So it is similar to your Google style user experience. So when you're using SAP BO Explorer, so you feel that how you search by using Google, the same user experience you face by using SAP BO Explorer. And it has limited analysis functionality as well. Your BO Explorer has a limited analysis functionality as well. So this is one of the component in your business objects. Then we have something called dashboards. So when we are talking about dashboards in older version, usually we call it as Excel sheets, because in SAP BO 3X, we have, instead of dashboards, we used to call it as Excel sheets. Your dashboard is a easy to use data visualization, wherein you can create interactive dashboards. So when we are talking about dashboards, we will also discuss about Lumira, because one of the participants, he wants to know about SAP Lumira as well. Lumira is also a kind of dashboard, but the only thing is in the earlier version, the name for this Lumira is Visual Intelligence. Okay, so before going to a dashboard called Lumira, first let us see what are the dashboards available in SAP. So when it comes to dashboards, first one is your dashboard designer, and the next one is Lumira. These are the different kinds of dashboard components which are available in your business objects. This is also a dashboard, Lumira. And the third one we have is Design Studio. These are the three different kinds of database components which are available in your business objects. So let us see. I don't know whether I can show you Lumira and Design Studio, but let me check. So first let us start with a dashboard designer tool. The look and feel you can see here. So business objects, SAP business objects, dashboards 4. This is the old dashboards. In older version, usually we used to call this as an Excel sheet dashboard, wherein it is a combination of MS Excel and Adobe Flash Player. So even I think so it's not yet configured. Okay, this is your untitled dashboard, wherein you can create different kinds of dashboards. If you go for a blank model, okay, it's not yet configured. Fine. Using your dashboard designer, what we can do is we can create data visualizations, and we can also generate interactive dashboards. In dashboards, we have different components like charts. We have maps. So many components are available in your dashboard. As of now, I couldn't able to show you because as this is a demo server, like I don't have the complete access to this server. So as of now, I can just show you how what is your dashboard is, but I couldn't able to show you how it look like. Then we have SAP Lumira. It's another dashboard. I think so one participant has asked about Lumira. If possible, I can show you Lumira. I'm not sure whether it opens. Yeah, this is your SAP Lumira. So what is the purpose of SAP Lumira is it combines data from multiple sources and create beautiful data visualizations. The older name for this Lumira is Visual Intelligence. Usually in the older version they used to call it as a Visual Intelligence. So this is your Lumira. See, if at all you want to create a dashboard by using Lumira, you can select any of these sources. Almost whatever the sources we have seen by using WebI Rich Client, almost you have the same sources. We have MS Excel, we have text, copy from a clipboard, connect to SAP HANA views, and download from SAP HANA Universe. See, if at all you have created a universe in IDT or UDT, even you can access that universe by using this dashboard. Even a query with SQL, you can run a freehand SQL on database, and you can even connect to your SAP BW system. SAP BW is one of the data warehousing system from SAP. So using your SAP Lumira, you can create colorful dashboard, or you can create a beautiful data visualizations by selecting any of these source. If at all you want to select any of these source, again you required a connection parameters, or you need to define a connection parameters in order to connect to any of these source systems. Then we have another dashboard component called as Design Studio. Design Studio. The advantage of this Design Studio is it has direct access to your SAP BW system. So when I'm talking about SAP BW system, it's nothing but a data warehouse. So your Design Studio has direct access to SAP BW system as well as SAP HANA. And the user interface for this Design Studio is HTML5. Usually what people say is it is an alternative to BEX, Web Application Development. So when I'm saying BEX is a kind of reporting tool, BEX or Business Explorer. It's a kind of reporting tool which is used by BW system. So in this Business Explorer reporting tool, there is a component called as BEX, Web Application Developer. So your dashboard designer, your Design Studio, your SAP Design Studio is an alternative to this BEX, Web Application Developer, and it's an Eclipse-based application design environment where you can create apps in iPads as well. So wherein you can create different applications. Even if at all you want to create different applications, you can even select the template category, whether you want to create this application for your desktop browser or for your iPad or for your iPhone. So SAP Business Objects came up with a design studio wherein you need a little JavaScripting language in order to work with this design studio. But if at all you are a person from BW background and you were using Bex web application development, it will be easier for you. Okay, after providing the names and all, you need to select the template, which template you want. You can select any template, then click on finish. On your left hand side, you can see different components. We have an analytic components. We have some basic components like buttons, charts and all these things. And also we have a container components. These are the different components available in your Design Studio. But Design Studio, as I told you, this component is specifically used by a BW person who is already worked in Bex web application development. This is about your Design Studio. Then we have few other components in SAP Business Objects. There is something called BO analysis for OLAP. BO analysis for OLAP. This is one of the component. The main purpose of this component is it's a web-based advanced analysis client for business analysts to run multiple, or you can say this component is used to run multi-dimensional analysis on OLAP sources. So when we are talking about OLAP sources, one of the OLAP sources is SAP BW system. So your BO analysis for OLAP, it is used to run multi-dimensional analysis on OLAP sources. And SAP recommends that customers adopt to this SAP BO analysis to support their strategic BI projects in the area of advanced multi-dimensional analysis by using OLAP data sources. So if at all you're a person who are working with OLAP data sources, then this is the right component, BO analysis for OLAP. Then there is another component called BO analysis for MS Office as well. The same BO analysis, one is for OLAP, another is for MS Office. So when we are talking about analysis for MS Office, it's an Excel-based OLAP analysis and it supports both BW as well as HANA sources, because most of the time there are some users, they'll be working on Excel-based analysis. So for them, this BO analysis for MS Office, it is very much useful, and also this component supports both BW as well as HANA sources. But instead of WebI, we have something called a desktop version, that is WebI Rich Client. Already I have covered this part, WebI Rich Client, wherein using WebI Rich Client, you can create interactive and flexible user interface for building and analyzing reports. So these are the different components of your SAP Business Objects, or you can say SAP BI 4.2. So in SAP BI 4.2, there are different areas wherein if at all you are from an administration background, you can go for a BO administration. If at all you are a developer, or if at all you're a modeler, wherein you can go for a designing part, designing a universe, or if at all you're an end user. So if at all you're an end user, you can work with an end user reporting components, like we have like we have WebI Rich Client, as well as Crystal reports. If at all you are looking for an expertise in dashboards, then you can go for a dashboard designer or SAP Lumira or Design Studio. But Design Studio is specifically designed for SAP BW users.
All right, let's test your knowledge. Here's a question for you. Which tool is used for creating and managing universes in SAP BO 4.2? Option A, Web Intelligence. Option B, Information Design Tool. Option C, Crystal Reports. Option D, Dashboard Designer. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Ready to dive into the world of SAP BO I 4.2? Our course page is here to guide you through. In this course, you will master SAP BO I 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO I 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
The purpose of data warehousing and what is the necessity of using a warehouse though we have a OLTP system or though we have a database. So in the introduction session, we are going to discuss all these things. Before going to the definition, what you see here is a definition of a data warehouse. But before going to the definition, let us understand what is a data warehouse is. Your warehouse is an environment and it's not a product. So the first thing we need to know is your data warehouse is not a product, rather it's an environment, and it is a architectural construction of information systems. So when we are talking about information systems, the data from your source systems, your source can be anything. The data from your source system can be loaded into data warehouse, and this data can be of any source. It can be from your Oracle database, or it can be from your Sybase, or it can be from your SQL Server. So both homogeneous as well as heterogeneous data can be loaded into your data warehouse. That is the reason your data warehouse is also known as an information systems. And the purpose of your data warehouse is it provides users with current and historical decision support information. So the main purpose of data warehouse is, one is it provides a historical information for analysis, and the second one is you can create your reports and you can perform your data analysis on this historical data which is stored in a data warehouse. Now when it's come to the definition here in this PDF or in this slide, you can see the definition of a data warehouse. You can see four areas here. The first point says the data warehouse is a time variant, integrated, non-volatile and subject oriented. So these are the four characteristics. You can say these are the four characteristics of a data warehouse. What are the four characteristics? The first one you can see here, it's a time variant, and the next one is an integrated, and the third one is non-volatile, and the last one subject oriented. So the definition itself says the collection of all this data, the collection of data. So the collection of integrated data, the collection of a subject data, or the collection of a time related data. All these data we will store in a data warehouse. And what is the purpose of storing all this data in a warehouse? It says in support of management's decision making processes. So in order to make a better decisions, okay, we will store all the data, the historical data into a data warehouse, so that whatever the data we have in a warehouse, this data supports the management people to make better decisions. So this is what the definition of a data warehouse. Now let's go to the next slide. Here we are talking about data mart. See, in the first slide we have seen something about a data warehouse. Now in this slide we were talking about a data mart. Now what is a data mart and what is a data warehouse? Okay. Now when we are talking about data mart, see what is the first bullet point says, your data marts are standalone small data warehouses limited to a subject area. So if at all say there is an organization and they cannot afford a big data warehouses, in that case, they can go for a data mart which is a subject related. For example, when I'm talking about subject, it can be your sales, or it can be your finance, or it can be your HR, whatever it is. There are different subjects. Okay. So when we are talking about data mart, your data mart is also a warehouse, but it's limited in size, or you can say your data mart is specifically related to a particular subject area. So when I'm talking about subject area, it can be your sales, or it can be your finance, or HR, so on. So when we are talking about data marts, this is a standalone small data warehouse. When we are talking about a data warehouse, it's a bigger warehouse where it contains different subjects in a one single data warehouse. When we are talking about data mart, it's a very small data warehouse which is limited to a particular subject area. And the second bullet point says we have dependent and independent data marts. So when we are talking about dependent and independent data marts, dependent data marts are dependent on some other warehouse. When we are talking about an independent data marts, without going for a data warehouse, directly you can go for an independent data mart which is related to a single subject area, and later on you can develop your own data warehouse. Later on you can add additional data marts in order to develop a bigger data warehouse. That is the second bullet point it says here. And the third bullet point says dependent data marts are extracted views of a corporate data warehouse. Just now, as I've discussed with you, your dependent data mart is nothing but it is dependent on a data warehouse which is already existed. That is your dependent data mart. And the last bullet point says independent data marts are those which are built directly against transaction system. So when we are talking about transaction system, say this is how it will be. So these are all your source systems. Let's say these are all the sources. Your source can be of anything. It can be your Oracle, or it can be your MS SQL, DB2, anything. Your source can be anything. It can also be an SAP source as well. SAP ECC is nothing but your source system. So all these sources, usually we call it as an OLTP system. So when we are talking about OLTP, your OLTP is nothing but online transaction process system. So the main purpose of data warehouse is whatever the data is coming inside these source systems or inside these databases, this data has to be loaded into a data warehouse. So this is your data warehouse. When we are talking about warehouse, usually warehouses are very big. Similarly, when we are talking about data warehouse, the size of this data warehouse is huge when it compared to your OLTP system. So this is your DWH, data warehouse. So in this slide, when we are talking about independent data marts are those which are built directly against transaction system. So when we're talking about independent data mart, it can be here. Say for example, I want to build an independent data mart for sales. So this data mart, this is actually a data mart. It's an independent data mart. This data mart can be built directly against your OLTP system. This is your OLTP system. Now this is about your data mart. So now we know the difference between a data warehouse and a data mart. So when we are talking about data warehouse, your data warehouse can contain different subject areas. It can contain different subject areas in a single warehouse. It can be your, say, HR. It can be your sales. Okay. So your warehouse is a bigger one which contains all the subjects, whereas your data mart is a smaller data warehouse which specifically contains a single subject area. That is what the last bullet point talks about. Now moving to the next slide, operational data store. So when we are talking about operational data store, the definition says it's a central data repository that consists of very detailed level transaction data. Now when we are talking about operational data store, your operational data store is a central data repository consists of very detailed level transaction data. See here, say suppose you have an ODS or DOS. Operational data store. So it contains what? A detailed level of data. See here what it says. It's a central data repository that consists of very detailed level of transaction data. When I'm talking about very detailed level of transaction data, for example, say there is a customer who has done a transaction. Say he has done transaction today morning. Then a detailed level, like in which outlet he has done the transaction, what are the products he has purchased, at what time he did the transaction, what is the total amount of the products which he has purchased. So each and every detailed information is available in your operational data store, So your ODS contains a detailed level of data. That's what the first bullet point says. And the second one says data warehouses and data marts are built by fetching data from ODS instead of transaction systems. So here what happens is, in this diagram, the second bullet point says instead of directly fetching the data from your OLTP system or your transaction system, the second bullet point says your warehouses means first the data goes to your ODS, and from ODS the data will be fetched to your data warehouse. So that is what the point says here. See here, data warehouses and data marts are built by fetching data from ODS instead of transaction systems. Your transaction system is nothing but your OLTP system. And the third point says ODS is data consolidation and integration point for several transaction systems. So here on your left hand side you can see many transaction systems. You have Oracle, you have SQL Server, you have DB2, you have even SAP source systems. So your ODS is the central point. So it can be here. Instead of here, your ODS can be here. Okay. So it's a central point for several transaction systems or several OLTP systems. So if at all we want to load the data into warehouse, first the data from source systems, it goes to ODS, and from ODS the warehouse will fetch the data. That is what this point says. And the next bullet point, it talks about more detailed data may not necessarily needed by data warehousing for analytical purpose. So when we are talking about data warehouse, usually we store historical data. And when we are talking about historical data, it doesn't mean we need to store each and every transaction of the data into your warehouse. For example, in this diagram, say today the 1,000 transactions has been taken place in an outlet, and this 1,000 transactions, say you want to move into data warehouse to perform data analysis. But it doesn't mean all the 1,000 transactions has to be loaded into your data warehouse. Whatever the information which you feel important, that information has to be loaded into your data warehouse. Whereas in your ODS contains all the detailed level of information. So that is what this bullet point says. More detailed data may not necessarily needed by data warehousing for analytical purpose. The last bullet point says ODS becomes hub for both data warehouses and transaction system. That's what you see here. See, if you have noticed here, your ODS is like a central hub. On the left hand side of ODS, you can see a source system. This is the source system, which is on left hand side, and on the right side of your ODS, you can see a data warehouse. So that is what the last bullet point says. It is a becomes hub for both data warehouses and transaction systems. Now, moving to the next slide, data warehouse versus operational databases. It's like OLTP versus OLAP. So when I'm talking about OLTP versus, before discussing OLTP versus OLAP, let me check once. Let us see the 4 characteristics of a data warehouse. Of course, it's not mentioned here. The 4 characteristics which we have seen in the first slide is subject-oriented, integrated, non-volatile, and time-variant. These are the 4 characteristics we have seen in the slide 1. So when I'm talking about subject-oriented, your data warehouse is specifically built on a particular subject area. That is nothing but your data mart. And when I'm talking about integration, see here, if at all I want to load data both from MS SQL as well as Oracle, this format is different and your target format is different. So what I need to do is I need to integrate and bring this format into a single target format so that I can load the data from source to my target. Here my source is, it can be anything, Oracle or MS SQL Server, and my target is data warehouse. That is the second characteristics. And the third one, non-volatile. The third characteristics of a data warehouse is non-volatile. Non-volatile is nothing but it's read-only. For example, this is your transactional system. Once the data from transactional system is moved or it's loaded into data warehouse, this data, it's read-only data. It is non-volatile. Why? Because this is logical, because what is the purpose of data warehouse we have discussed? The purpose is it enables you to analyze what has occurred. And this analysis is based on the historical data which you are moving into data warehouse. So it is logical because the purpose of data warehouse, it is to maintain historical data which has been occurred, and based on that you can enable your analysis. That is the reason whatever the data you have in your data warehouse, it is a non-volatile or it is a read-only data. That is the third characteristics of a warehouse. And when we are talking about time variant, usually time variant, what happens is, in order to, if at all we want to discover some business trends, usually analysts, they need large volumes of data. Okay, so if at all they need large volumes of data, this large volumes of data is available in your warehouse based on change over time. For example, when we are talking about time variant, if you take the year, say Q1, Q2, Q3 and Q4. So already like we are in Q2. So the Q1 information is already loaded into warehouse. Q2, now it's loaded into again a warehouse. In Q2 again we have April, May and June. So already we are in the middle of Q2. So time variant is nothing but the data will, based on the data which is loaded into the data warehouse. For example, in the month of May, some transaction has been loaded into data warehouse. Based on that, the analysts will come to know, okay, in this particular month, these products we can move quickly, or these products are not at all moving. So when we are talking about time variant, your time variant will help the analysts to discover the trends in business. So in the month of May, okay, these products can be moved in the month of May. And in the month of June, okay, we keep some other products, so that June month, many customers are very much preferred to purchase these products. So your time variant will help the analysts to discover trends in the business. That is the fourth characteristics of a data warehouse. Now going back to the slide, the difference between an OLTP system and a data warehouse, that is nothing but your OLAP. See, both are databases. Even your OLTP system is a database, and also your OLAP, that is your data warehouse, also a database. But the only difference is, in your OLTP system, you will be storing transaction data, and in your OLAP system, you will be storing the historical data which is used for analytical processing. That is the only difference. Both the systems will store the data. OLTP system particularly designed to store transactional data, whereas your OLAP system is designed to store huge volumes of historical data so that an analysis can be done on your OLAP system. That is what this slide talks about. See here, major tasks of traditional relational DBMS. That is the first thing. Second one, day-to-day operations like purchasing, inventories, etc. So all these transactions, day-to-day transaction operations can be stored in your OLTP system. When we are talking about OLAP system, major tasks of data warehousing system. So whatever the data you feel it's important, or whatever the data it's important for the client, that data will be loaded into data warehouse so that analysis can be done on that historical data which is available in data warehouse. Not all the transactions which are available in your OLTP system has to be loaded into data warehouse. Now moving to the next slide. Of course, here they have given so many areas, the difference between an OLTP as well as OLAP. We will see few things here. See, when it comes to, see, it will have a limited amount of historical data. For example, as you're talking about a banking domain, okay. So hardly the banking system, they'll be storing a data of 3 to 4 months of data. But what if I need more than 1 year of more than 1 year of data? Say I want a transaction, I want to see my last year's transaction. In that case, your banking system which is operating on OLTP system, it will not provide that information. Maybe they'll tell you, you come on some other, they'll give you some other time. Meanwhile, what they do is they'll refer the OLAP system and they'll get the information, because that information is available in a data warehouse. They need to go for that data which is available in warehouse. Then they should give you the transactions, last year transaction. But immediate transaction, if you require, say, it's a 3-month bank statement you required, or maybe some 4 months, immediately then and there they'll give, because that data is available in your OLTP system. It depends on how much time period of data they want to store in their OLTP system. But most of the time, the majority, the very old data will be moved to data warehouse.
Yeah, got it. Another thing which I wanted to discuss is that you are asking that, okay, OLTP is one, OLAP is one, and in between the ODS where you apply the business rules. So both of them systems are actually databases only, right? It might be Oracle. So OLTP might be multiple, because you're taking input from multiple and putting it into a single point. Like so Oracle, MS SQL, DB2, many will be there, but it will be going into one kind of database system.
Okay, because that's what in the characteristics we have integration, something called integrated, time variant integrated, because the data can come from heterogeneous systems. It doesn't mean the client will have only single database. Okay, so here they have given so many differences between OLTP as well as OLAP. Let us take 1 or 2 areas. Okay, so if you take the designing of your OLTP system, for example, the fifth one. The third one, sorry, the fifth one, database design. So when we are talking about database design, your OLTP system is highly normalized with many tables, and it is application oriented. So usually, like for designing of databases, we'll be using the ER model, entity relationship model. But the same designing of data warehouse. See, both are databases. Your OLTP system is also a storage area, whereas your warehouse is also a huge volumes of storage area. But the designing is little different. Your OLTP system is particularly or is specifically designed in order to store transaction data. That is the reason most of the time they'll be using highly normalized. So many tables will be there, and there will be relationship between all these tables. So that is what your database design is, an ER model. And when it comes to OLAP system, what it says here, typically denormalized with fewer tables. So in your OLAP system, when you're designing an OLAP system, you won't find so many tables. Rather, you will find only few tables, and these tables usually we call them as a dimension table and fact table. Of course, we will be discussing that in the coming slides. And when you have less tables, obviously the joins will be less. And this part says use of star schema, subject oriented. We will be discussing all these things. What is star schema and what is a dimension table, what is fact table. So this is one area where you can see the difference between an OLTP system as well as an OLAP system. And the second area where you can see is, see, when it comes to queries, because the main purpose of data warehouse is we want to analyze the data which is available. So when it comes to queries, it says here relatively standardized and simple queries which returns relatively few records, because the amount of data which is available in OLTP system, obviously it is very less compared to the amount of data which is available in a warehouse. And in warehouse, often complex queries involving aggregates. So this is another area where we can see the difference between an OLTP system as well as an OLAP system. So we have seen only two things here. Of course, like other things, like you can just go through it, because one is the designing of both an OLTP system as well as an OLAP system, and the next one is queries, because for analysis and all we will be writing so many queries. In data warehouse, when you write a query, this query can retrieve some millions of records. But if the same query, if you try to write in OLTP system, it returns very few records. So this is another area. So this is the difference between an OLTP and OLAP. If you were already working in some ETL tool or some other data warehousing tool or some other thing, all these things are very basic. So in this session, what we are going to discuss is very basics. We are going to discuss very basics, because this is the prerequisite to learn SAP Business Objects. You should have a little knowledge on database concepts as well as a little knowledge on data warehouse concepts as well. So you're talking about interaction. So interaction in the sense like whatever we are interacting in this session.
Yeah,
okay?
no,
Now
as in it's mentioned for OLTP, it's mentioned interaction, drill down. What does that mean?
Okay. So you're talking about here interaction. Okay.
Yeah, drill down.
Okay. So drill down is nothing but it is an area wherein you can move from one level to another level. For example, right now you're in Q2, 2016, we are in Q2. So from Q2, you can, from quarter actually, this is the quarter, from Q2 to, you can move to a month. So when I have moved from Q2 to month, it will be March, it will be April, May and June. That is nothing but you're coming one level down, drilling one level down.
Okay,
and from month you can go to week, from week you can go to day. It's like that. Okay.
Yep,
so
yep.
Other things you can just go through it, because these are all the very basics. You can go through it. Other things, whatever be required in order to learn SAP Business Objects or 4.0 BOBI. So we will be focusing more on those things. Now coming to the next slide, data warehouse process. So on your left hand side you can see there is a small diagram here, heterogeneous source system environment. When we are talking about heterogeneous source system, it is same as the one which I have given here. Here we have three different source systems, system 1, 2 and 3. It can be Oracle, DB2 and SQL servers. And by using ETL process, the loading process, the data will be loaded into data warehouse. So in order to load the data into warehouse from OLTP system, we required an ETL process. That's what the point says here. See here, classical data warehouses copy data into OLAP cube in a 3-step process. So in order to move data from system 1, 2 and 3 to data warehouse, it's a 3-step process. So this is the source system and this is your data warehouse. So I have data here, the transaction data. This is my OLTP system. And if at all I want to move this data into my data warehouse, to move the data from OLTP system into my data warehouse, it's a three-step process. What is the first step? First step is extraction. First step is extraction, and the next one is, once the data is extracted, it has to be transformed. So next step is transformation. And finally, this data has to be loaded into the transformed data has to be loaded into data warehouse. So this is a 3-step process. Extract, step 1, then transformation, step 2, then finally loading, step 3. That is what this point says. Classical data warehouses copy data into OLAP cube in a 3-step process called extraction, transformation and loading. So of course in market there are many ETL tools available in the market to do this process. Usually we call them as an ETL tool. So we have different ETL tools in the market, like we have Informatica. It can be anything. Even when it comes to SAP, you have SAP BW or even your data stage. This is also one ETL tool. So there are many ETL tools available in the market. So using this ETL tool, the data which is available in your OLTP system will be copied or will be loaded into data warehouse. Now you can see this diagram here. So once the data is loaded into your warehouse, this data is based on this data, we'll write queries and we will create reports on this. So the reporting part comes here. This is your business objects reporting. Okay, so in this module, whatever we are learning is, we are focusing on the reporting part. That is your SAP BO BI 4.2. Okay, this is the one. So once the data which is moved from OLTP systems into data warehouse, by using your reporting tool, that is business objects, we will execute queries on this data and we will create reports in your business objects. Not only reports, there are many things. We can even design universes. We can even create dashboards. Many things are there. We will be seeing all these things. To understand this slide, the final part is reporting. The same structure you can see on your right hand side. See, on your right hand side they have given the tables, and for the tables they have given ERP. Of course the source here they have used this ERP system. So when we are talking about ERP, it can be your SAP source as well. So extract, transform, load, and finally the data is loaded into data warehouse. When we are talking about OLAP cube which is designed based on multi-dimensional database. When we are talking about multi-dimensional databases, for example, if you take SAP BW system, your SAP BW system, the data will be stored in info cube. So that is the reason, see here, they have given OLAP cube and also info cube. And if you take some other multi-dimensional databases, we have Hyperion and we have some other, even Microsoft has some other multi-dimensional databases. Till now we are talking about a relational databases. Here in the previous diagram, whatever we discussed here is we have discussed about Oracle. These are all relational databases, SQL Server or DB2. Okay. So when we are talking about OLAP databases, it can be your SAP BW Cube or it can be your Hyperion. These are all multi-dimensional databases. So the point here it says is you can build or you can load the data even into an info cube or OLAP cube. Because your data warehouse, when we are talking about data warehouse, again there is an underlying database for this data warehouse. For this data warehouse, again there is an underlying database. This underlying database, it can be anything. It can be your Oracle or it can be your SQL Server. Because this again the data has to be stored in your warehouse. So here the point is when we are talking about info cubes or OLAP cube, and specifically when we are talking about OLAP cube, if at all you have created a universe based on a multi-dimensional databases, then it is known as an OLAP cube. Usually for OLAP we will be using SAP BW system because in our content, in our course content, we have an introduction to SAP BW system as well. Means like almost in that introduction part, we will be covering around 30 to 40% of SAP BW system. We will be seeing that how to create cubes. There are different targets in BW system. We will be discussing that in the coming sessions. As of now, all we need to understand is whatever the data you have in heterogeneous source systems, all this data can be loaded into data warehouse with the three-step process known as ETL, extraction, transformation, and loading.
Hey there! Ready to dive into the world of SAP BO I 4.2? Our course page is here to guide you through. In this course, you will master SAP BO I 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO I 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
So you can notice here carefully in this architecture of databases, at the bottom of this slide, you can see any source. So you can load data from any source. It can be your SAP source or it can be your non-SAP source. From this any source, the data will first move to staging area. Usually we call it as persistent staging area. It's just the data will first move to staging area. From staging area, it goes to ODS, then warehouse, and finally to data mart. See, this diagram I can draw like this. So this is your any source. This will be your staging area, then your ODS, then your data warehouse. Any source, from any source, the first goes to persistent staging area. We call it as PSA. Then from PSA, it goes to DS or ODS. Then from here, it goes to the warehouse. It goes like this. From any source to PSA, PSA to ODS. In ODS, you'll have the detail level of data. That's what we have seen earlier. And from ODS, finally, the data will be moved into warehouse. The same structure you can see here. Any source, persistent staging area, operational data store, and data warehouse. It can be your data warehouse or it can be your data marts as well. See, as I told you, the difference between a warehouse and a data mart, your warehouse is nothing but the bigger one which contains all the subject areas like sales, HR, finance, so on. Whereas when we are talking about a data mart, your data mart specifically is designed for a single subject area. That is what this slide talks about. Now moving to the next slide. See, the same thing, whatever I have shown you in the paintbrush, the same thing. You can see here SAP source system, that is ECC. SAP ECC is nothing but it's an SAP source system. And when we are talking about non-ECC or non-SAP source systems, it can be your other databases like Oracle, DB2, SQL Server, and so on. And here they have given the definition for business intelligence. What are we talking about? Because when we are talking about business intelligence, we should know what is BI or what is business intelligence. See, I'll tell you. Your business intelligence is nothing but any source. The first thing is any source. So in your source, usually you will have all the data. Okay. So transforming this data will be transformed into information once it reaches your data warehouse. Data into information, and this information, again, we will transfer this information into knowledge. Transfer this information into knowledge. But how we will transfer this information into knowledge? By creating reports. So your reporting tool comes here. This is the reporting tool. That is your business objects, BO. Okay. So your business intelligence is nothing but transforming data into information. So once the data which is in your OLTP system, it's loaded into data warehouse, it becomes an information. From this information, you can create some reports. That is the reason your warehouse is also known as an information system. So that's the reason, transforming of data into information and information into knowledge. So how we will get the knowledge? By seeing the reports. Transforming data into information, information into knowledge. Means that's nothing but creating your report. Once your report is created, then when the business users perform analysis on the report which is created, then that is nothing but your decision making. So your business intelligence is nothing but, in one word, BI is equal to data into information, transforming data into information, then information into knowledge, and knowledge into decision making. So this is your business intelligence. That is what they're trying to tell you in this slide. So you can see here, there's a lot of data in ECC system as well as non-ECC or non-SAP system, and this data has been moved into data warehouse. Your SAP BW here in this slide is nothing but your data warehouse, and finally to this data warehouse, the reporting tool, that is nothing but your SAP Business Objects reporting tool, is connected to this data warehouse. Thereby you perform reports and analysis. That is your business intelligence. Now going to the next slide. So just now we have seen business intelligence, the definition of business intelligence. They have given detailed information here. What is BI? Okay, so the same thing, whatever I have shown you in the paint, they have given the same information. Operational data, then analysts, managements, finally decision making. So here it says, business intelligence recovers also a link between people profile and information to use. So that is the reason everywhere we are talking about BI, business intelligence, and there are so many BI reporting tools available in the market. The reporting tool which we are learning here is SAP BO BI 4.2. Now in the next slide, we will see about data models. In previous slides, we have seen the difference between an OLTP system and OLAP system. And for OLTP system, I have told you like it's a ER model, entity relationship model. So that's what we are going to discuss here. So data model, the first bullet point says the two data models relevant in data warehouse are, one is entity relationship model and the other one is multidimensional model. This is the first bullet point says. And the second bullet point says entity relationship management. The first one, entity relationship model. It's explaining here about the ERM, entity relationship model. What it does, it produces a data model of the specific area of interest using two basic concepts. One is entities and the other one is the relationship between entities. It's nothing but your table and the relation between these tables. For example, say you have a customer table and say you have a product table. So you can perform a relationship between these two, or you have a employee table and you have a department table. You can perform a relationship between these two tables. So that is what it says. ERM produces a data model of the specific area of interest using two basic concepts. So first we'll create tables and we'll make relationship between those tables. And the last bullet point talks about MDM, multidimensional model. So again, this model consists of two areas. One is numerical facts or key figures in BW terminology. That is one thing. Usually we call it as a fact table. So of course, like we will see the schema and all. We will discuss about schemas and all. At that point of time, maybe you'll have a clear idea on this. So the first one is numerical facts or key figures, or you can also say as business measurements. That is again another terminology wherein people will be using. And the second one is dimension attribute, meaning the business terms that describe these facts. So when we are talking about dimension attributes, is nothing but the attributes which are available in your dimension table. So these are the two types of data models: entity relationship model, multidimensional model. In entity relationship model, we'll have a table and we'll make a relationship between those tables. In multidimensional model, we'll have dimension tables and fact tables, and we'll perform a star schema model over there. This slide talks about these two. Now going to the next slide, I think so they have given a clear information on ER model. You can see here, of course, you can see different tables here, and there is a relationship between all these tables. See the first point, what it says, determine the entities. That is nothing but basic business terms. Then determine relationship between the entities. Now if you notice here, you can see a relationship between each and every table. And the third one, determine attribute information for each entity. Each and every entity, we need to determine an attribute information. And finally, actually when we're talking about ER model, it's a normalized. But when we are talking about multi-dimensional model, it's a denormalized. You can see that in the next slide maybe. No. In the same slide, they have given a different relationship. See here you have a customer, material, salesperson, and you can perform a relationship between these three tables. When we are performing relationship, usually this is how we do. We will define cardinality like 1:1, 1:n, n:n, so on. Like of course we will be discussing all these things when we design universe. In business objects we have a module called IDT, Information Design Tool. So when we are going to see in that module, at that point of time, we will be seeing these relationships. Now going to the next slide, multi-dimensional model. So this is what we need for data warehouse. See, a data warehouse is based on multi-dimensional data model which views data in the form of cube, data cube. So when we are talking about data warehouse, usually this data warehouse is built based on multi-dimensional model. And when we are talking about multi-dimensional model, it contains facts, numerical facts. That's what we have seen in the previous slide. It contains numerical facts or business measures as well as dimension tables. That is your multi-dimensional model. So your warehouse is built based on this model, MDM model. And the second bullet point says a data cube such as sales allows data to be modeled and viewed in multiple dimension tables. Of course, we will discuss all these things in detail when we see star schema model. We will be seeing like how your fact table is, what is your fact table is, and how this how all the dimension tables are connected to the fact table. All these things we will be discussing in star schema model, but they have given a little information on this, a data cube. For example, if you take a cube called sales, this sales cube has the following dimension tables. You can see here the dimension tables. What are the dimension tables it has? One is item, and the other one is time. So in this case, they have taken only two dimension tables. One is item dimension table, which contains these attributes, item name, brand, and type, and the other one is time. And the next one is fact table. So these dimension tables will be connected to a fact table. And what does your fact table contain? See, it contains business measures. It contains measures and keys to each of the related dimension tables. So whatever the keys you have in dimension tables, via this key, the dimension table is connected to the fact table. We will see this in detail when we are discussing about star schema model, how your dimension table is connected to the fact table. Now, moving to the next slide. Multi-dimensional data. They have given the overview of how your cube looks like. See here, it's like a cube. So the advantage of storing data in the form of cube is you can view the data in different directions. You can analyze the data region-wise sales. You can analyze the product-wise. You can analyze monthly sales. So your cube can be turned. It can be moved. It can be turned around, and you can view your data in different perspectives in this cube. That is what the advantage you have in multi-dimensional data. So you can view your data in different perspectives so that you can analyze them region-wise sales revenue or product-wise sales revenue or monthly sales revenue. You can analyze by using different perspectives. This is an example, that's it. Of course, we will be designing this cube in SAP BW because in module 1 we have an introduction to BW system as well. So I'll show you how to design this cube in SAP BW system. Of course, the same thing they have shown in this slide, a sample data cube for product, date, as well as country. The same thing. So we will be seeing how to create a cube and how to load the data from OLTP system into cube. So when we discuss in this model, when we go further, maybe in session 3 or session 4, I'll be showing you how to load the data into the cube. Now they have given some information about dimension table. What is dimension table? It says, the first bullet point says dimension tables are grouping of related data items. It is like, usually it will be like this. So these are all your dimension tables. And this is your fact table. This is just an example I'm using here. Let us say this is your time dimension. This is your product dimension. Then this is your store dimension. These are the 3 dimension tables, and I have taken one fact table. So when we are talking about dimension table, this dimension tables contains some characteristics. So let us say, I'll give few characteristics. Say you have year, then you have month, say week. In time dimension. Similarly, in product dimension, say you have a description of your product and brand. And in store dimension, say you have the store location, say state, as well as region. This is how your dimension tables will look like. In your dimension table, you will have all the attribute information. And in fact tables, just now we have seen your fact table contains measures, business measures or key figures. So your fact table contains measures, business measures. For example, unit cost and units sold. This is how your facts will be. And when we are talking about star schema model, these dimension tables, all these dimension tables will be connected to your fact table. Usually this is how it will be. Of course, we will be seeing this in detail in the coming sessions. So that is what they are trying to explain here. Your dimension tables are grouping of related data items. So what is the grouping of related data items here? For example, if you take product dimension, the related items are description, brand, say even it can be a category, so on. That is the first point it says. Second point, master data is referred as characteristics. So one point you need to understand is, when we are talking about master data, it is static. Okay, so it doesn't change very frequently. So in your star schema model, all your master data information will be maintained in dimension table. So it is, your dimension tables are static in your star schema model. That is what the second bullet point it says. It's referred as characteristics. And the third point it says, a dimension table consists of dimension ID. Okay, so here, of course, like you'll be having, for each and every dimension, you'll have a dimension ID. For example, if I'm talking about time dimension, it can have a time key. When I'm talking about product dimension, it can have a product key. Store dimension, it can have a store key. So that is what the third bullet point says. A dimension table consists of dimensional ID, which is nothing but it's a primary key. This is about your dimension tables. Now coming to fact table, see what it says. Fact tables consists dimension IDs and measures. Here in this diagram I have given only measures. This we call it as measure objects. So your fact table also contains what it says here, keys. It contains dimension IDs and measures. So when we are talking about dimension IDs, so whatever the dimension ID, for example, you have time key dimension ID here. It's a primary key here. Then it will come here as time key. It will be your foreign key. Similarly, if I talk about product dimension, it's a product key. So here you have product key, and this will be your foreign key. That is what the first bullet point says. Fact tables consists dimensional IDs and measures. Of course, measures we have here. Unit cost and unit sold. Both are measure or key figures. The second bullet point says, when transaction data loaded, fact table is maintained. So all your transaction data will be loaded into your fact table. So this is nothing but your storage area. And out of all these four tables, your fact table is the largest table. Out of all the four tables, your fact table is the largest table. Of course, we will be seeing how much data is, when we design a universe in IDT, I'll be showing you how many rows does your fact table contains and how many rows does your dimension table contains. We will be seeing all these things when we discuss IDT. Now going to the next slide, star schema. Of course, already I've shown you. The definition they have given is a fact table in the middle connected to a set of dimension tables. So your star schema is nothing but all your dimension tables connected to a centralized fact table, or a fact table in the middle connected to a set of dimension table. If you notice here, see, all these dimension tables are connected to your fact table. That is what the simple definition of a star schema. See, in this case, you can call this as a sales fact, and this dimension can be your time dimension, store dimension, product dimension, or some other dimension. Okay, so your star schema is nothing but all these dimension tables. Okay, all the dimension tables are connected to a centralized fact table. And these dimension tables are denormalized dimension tables. So whatever the dimension tables you see here in the star schema model, all these dimension tables are denormalized dimension table. They are not normalized. Going to the next slide, the first bullet point says in a star schema, the ways in which we characterize all transactions are collected together in dimension. That's what we have discussed, because in star schema model, what it does is all characteristic transactions, like whether it's product information, all this product information is collected in the product dimension. All the store related information is collected in the store dimension. All the time related information collected in the time dimension. That is what the first point says. Second point says the facts are the statistics and key figures. Of course, we have already seen this. Fact table is nothing but where it contains the statistics, the numbers of the business. And also it's also called as key figures. See, that's what it says here. Customers used to understand the business process. So based on the statistics, you will understand where your business is going, where the business is going. So how much revenue we are making based on this statistics or based on the key figures. And the third bullet point says the dimensions provide answers to questions about who, what, and when. Of course, like who is the top customer. Okay. For example, next, like what can be our, which is the most moving product. So all these questions can be answered by using your dimension tables. So this is just a sample points they have given here, but when we really create a dimension table in SAP BW system, that is where you'll clearly understand why we are creating this particular dimension and what type of data we are moving into this dimension table. That is where you'll have a better understanding when you see this information practically. Example of star schema. The same example they have given time. This item is nothing but your product, location, so on. See here, the same thing, whatever we have seen here, the same information they have given in this slide. Of course, we will be discussing in detail about this star schema model, and also we will discuss about extended star schema model, because the ETL tool which we are going to see is SAP BW system. And when we are trying to create InfoCube, before creating InfoCube, I'll explain you what is an extended star schema model. This is a star schema model. Whatever the diagram you see here, it is a star schema model. But along with it, we will also see an extended star schema model. The same thing they have given in detail. Okay, customer dimension. Then all this information, you have a material dimension, time dimension. So in the center, you can see the fact table. And for each and every dimension table, you can see the primary key. See here for customer, this is the primary key. For material, this is the primary key. And for time, this is the primary key. So your fact table contains keys and business measures, or keys and key figures, whatever it is. Because it can be called as measures, it can be called as key figures, it can also be called as facts. Anything it can be called. So in this case, quantity, sales, credit memos, open orders, all these things we call them as facts or measures. Whereas below MCT, whatever the keys you have, we call them as foreign keys. So in your star schema, you have all your dimension tables connected to a centralized fact table. You can see here, in the center you have the fact table, and all these three dimension tables are connected to the fact table. The same example they have given here. Okay, so this is what the introduction part of your data warehouse. We have just seen an introduction to data warehouse, and there are many other things which we need to see in BW system, because your BW system, it's an ETL tool as well as it's a reporting tool as well. But most of the time when we're discussing BW system, we will focus on the InfoCubes and different targets which your SAP BW system contains. Is an introduction to data warehouse, because if at all we want to learn SAP BOBI 4.2, this is a foundation. This is like a foundation. You should know what is dimension table, what is fact table, what is this PR model, and what is this multi-dimensional model, what is fact table, what is dimension table. All this terminology, you should be familiar with all this terminology. In order to understand these things, we have in the introduction part, I have discussed about data warehousing concepts. Because this is the base in order to understand even your SAP BW, because in the coming sessions we will be seeing how to load the data from OLTP system into a data warehouse, and that we will be seeing by using SAP BW system. Once the data which is loaded into data warehouse, then we can connect a reporting tool to this data warehouse which is in SAP BW system, and we can perform reports and analysis.
If I understand correctly, in the star schema, the MDM model, multi-dimensional model, so there are dimensional tables, and these are all denormalized data, right? So that means it can have duplicate data in each and every table based on a primary key, to which it's going to connect to a fact table, which will be acting as a foreign key, right?
Yes.
So each and every table in the star schema will be loaded individually by an ETL tool, or like how you're going to load it, like
okay.
Or
so you mean to know like how the data will be loaded into this each and every dimension table? That's what you're saying.
So it's gonna be individual, or because these are independent tables from each other, right?
Yes. Okay. Each and every dimension table is an independent one. Okay. So into this independent dimension table, for example, we have in a source system, you have a product table, and that information you can load it into a product dimension table. And you have a store table in your OLTP system. That store data will be loaded into a store dimension table. So all these are independent dimension tables, but connected to a fact table.
Yep. So how the fact table, so it has the foreign keys that, okay, I got it. It will have the same data which might be there in your dimension tables by a foreign key. But what is this measure? Like, is it some kind of a formula, or something which is stored up in there, or what is measure?
Okay. See, the thing is, when in your dimension tables, usually you have a primary key, right? Okay. So using keys only, we are moving the data from dimensions. See, if you notice here, if you notice here, whatever the data you have in this fact table, okay, you have fact data as well as key information. For example, if at all I want to know my customer, who is my customer. So using this key, I'll refer to the customer dimension table. Okay. So whatever the data you have in dimension table, this data will be moved to the fact table using the keys. And when you have a primary key in your customer dimension table, obviously a fact table should have a foreign key.
Yep.
The data is moved from.
It's just kind of a numeric field in a table in fact table, which you're saying as major IDs. Okay. Okay.
See, of course, we will be discussing in detail all these things in detail, because we have something called SIDs, how these numeric IDs will be generated in details in the coming session. Because this is just an introduction session, I have just given an overview of a data warehouse. You should be clearly thorough with this session. The concepts of SAP BW system. When we are discussing the concepts of BW system, we will discuss about the star schema as well as extended star schema, how the data will be moved from dimension tables to fact table, and what are the different targets we have in the data warehouse. All these things we are going to. So that's the reason, if you have any questions in this introduction session of data warehousing, intro to data warehousing, you can please ask your questions so that I will answer you.
All right, let's test your knowledge. Here's a question for you. What is the purpose of the SAP Business Objects Explorer in SAP BO BI 4.2? Option A, to create pixel-perfect reports. Option B, to design interactive dashboards. Option C, to explore and analyze data intuitively. Option D, to create OLAP cubes. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Ready to dive into the world of SAP BO I 4.2? Our course page is here to guide you through. In this course, you will master SAP BO I 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO I 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
Anyway, we will see what is a star schema in detail. Before starting up with star schema, first let us see what is a schema. So when we are talking about schema, a schema is nothing but it's a collection of a few database objects. So when I'm talking about database objects, these objects includes your tables, it can be your views, indexes, even synonyms, so on. So when we collect all these database objects together, we call them as a schema. And the first schema which we are going to discuss now is a star schema. Usually, if you take any data warehousing project, most of the time they'll be using star schema, and your star schema is a denormalized model. So let us discuss one by one. First, let us see what is the dimension tables and what is a fact table. So when we are talking about dimension table, so this is how your star schema will look like. Of course, in my previous session, I have given this diagram. So this is your fact table. These are all your dimension tables. Now coming to the star schema model, this is the fact. These are all your dimension tables. So first, let me say it's a time dimension. Then you have a product dimension. Then a store dimension. Now, what is a dimension table? Before talking about dimension table, let us see something about what is a metadata. Usually when we are talking about metadata is nothing but which models the organization of data and the applications in different OLAP components. For example, I can say your metadata is like a container. Okay, it's not a content, rather it's a container which holds the content. So your metadata is like a container. For example, if you take a water bottle, your water bottle is a container, and this water bottle holds the content called water. The same way your metadata is nothing but it's a container information, and it doesn't contain any content. Most of the time when we say about metadata, usually people say it's data about data. When we talk about metadata, usually most of them say it is data about data. And your metadata describes objects. So when we are talking about metadata describing objects, these objects can be your tables in your OLTP system. And also it records which application refers to various pieces of data. Your metadata also refers to a particular application which refers to a various pieces of data. So your metadata is nothing but it talks about data. So data about data, and it doesn't contain, it is a container where it holds the content. That is your metadata. Now when we are talking about dimension table, the first one, if you see here, the first row, these are all your dimension tables. All these dimension tables will be connected to your fact table. All these dimension tables will be connected to your fact table. And what is the definition of a dimension table? When we are talking about definition of a dimension table, it's not here. The definition they have not given in this particular PPT, but the definition for a dimension table, you can say your dimension table is known as a lookup or a reference table. So when we are talking about dimension table, it's known as lookup or reference table. So your dimension table is known as lookup or reference table, which contains relatively static data in the warehouse. So your dimension table contains what? It contains static data in your data warehouse. That is the one thing. The first thing is your dimension table is known as lookup or reference table, which contains relatively static data in the warehouse. And the next point for dimension table is your dimensions table stores information you normally use to contain queries. So when we are talking about, say, if you're talking about product dimension, if you're talking about this product dimension, what it does, it stores the information which is used to contain queries. So you can write all the product related queries in your product dimension. That is the second area. The first area is your dimension tables known as lookup or reference table, which contains static data. And the second area is your dimension table store information you normally use to contain queries. So store information for queries. This is the second point for dimension tables. And the third point, if you see, your dimension tables are usually textual and descriptive, and you can use them as the row headers of the result set. When you're talking about dimension table, your dimension tables are textual and descriptive. For example, in this diagram, if you take product dimension, so your product dimension will have a product key, then you have a detailed information or a descriptive information like product description, product brand and category, so on. So your dimension table contains textual and descriptive information. So this is the third area. First one is your dimension table is a lookup or reference table, contains static data. Second one, it stores information for queries. And the third one, dimension table, usually textual and descriptive. So this is about your dimension tables in your star schema model. It can be any dimension table. And when we are talking about SAP BW system, because the warehouse which we are going to build is an SAP BW system. Most of the time we will be connecting to SAP BW system. Of course, we will also create reports and universe on non-SAP sources, but still our main focus will be on SAP BW system. So in SAP BW system, the maximum number of dimensions which you can create for an info cube in SAP BW system the maximum number of dimensions you can create for an info cube is 16. 16 is the maximum number of dimension tables. So in this diagram, if you notice, I have drawn 3 dimension tables. But for SAP BW system, for an info cube, if at all you want to create a dimension table, the maximum will be 16 and the minimum will be 4. 16 will be the maximum and the minimum will be 4 dimension tables for SAP BW system. Now this is about your dimension tables. Now coming to fact table. Fact table is the below one. Usually we call fact tables are the bigger tables. This one. Fact table. This is your fact table. So fact tables are the large tables in your warehouse schema that store business measurements. Yesterday already we have seen a fact table will store business measures or key figures. For example, unit cost or units sold. So these are all the business measurements. So your fact table is the largest table in your schema that store business measurements. That is one area. And the second one is your fact table typically contains foreign keys to the dimension table. For example, these are the dimension tables. In this diagram, we have 3 dimension tables: time, product, and store. Let me take the primary keys for time. Say it is time key. This is the primary key, product key. Then we have a store key. Now, these dimension tables are connected to your fact table by using this, internally connected to the fact table by using these keys. So when I'm talking about keys, the same key, it will appear here, say time key, but whatever the key you see here, it is a foreign key. Whatever the keys you see inside your fact table, it is a foreign key. So product key, again it's a foreign key. Then you have a store key. It's a foreign key. So your fact table typically contains foreign keys to the dimension tables. That is the second one. The first one is your fact table contains business measurements. That's what we have seen here. These are all your business measures. And these are all your foreign keys. And your fact table represents data, usually numeric and additive. So whatever the data you have in your fact table, the data usually it's numeric and additive, and it can be analyzed and examined. So whatever the data you have in your fact table can be analyzed and it can be examined. And when I'm talking about fact table, your fact table is also a table that contains summarized numerical and historical facts. So your fact table contains summarized numericals and historical data of your facts. So this is about your fact table. So in your whole SAP star schema model, your whole star schema model, your dimension table contains static data and it stores the information for queries, whereas your fact table contains measure objects or business measures, wherein it contains the summarized numericals and historical data of the business measures. So this is about your star schema. Now coming to the definition of your star schema, in one word definition you can say like this: the star schema definition, in a single word you can see it consists of denormalized dimension table. So whatever the dimension tables you see in the star schema model, all these dimension tables are denormalized dimension tables. So your fact table consists of denormalized dimension tables connected to a centralized fact table. So in simple or single line definition, you can say your star schema consists of a denormalized dimension tables connected to a centralized fact table. So we need to understand this star schema model clearly, because the next schema which we are going to see now is, it's a BW extended schema. Of course, maybe this terminology is new to you. Usually, along with star schema, people will talk about snowflake schema. This is another kind of schema. We call it as a snowflake schema. But in SAP BW system, we call them as BW extended star schema. In SAP BW system, we call them as BW extended star schema. Now let us see BW extended star schema. This is very important for us, BW extended star schema, because based on this model, we will design different targets in our SAP BW system. Because in the unit 1, we have few topics which are related to SAP BW system. So what is the schema we are going to create in SAP BW system? What are the targets which we are going to use? So all these things we will be discussing in detail in SAP BW introduction. So before discussing that BW extended star schema, let me give you just an overview of SAP BW system. Of course, in this slide we don't have anything about SAP BW system. Let me give you an overview of SAP BW system. SAP Business Warehouse. BW stands for Business Warehouse. So your SAP Business Warehouse, it's SAP's entry into data warehouse market. See, there are so many data warehousing tools available in the market. We have different ETL tools, we have different OLTP tools, we have different modeling tools. So when we are talking about data warehousing, basically your data warehouse, as a data warehouse consultant, most of the time you will be involving in designing a model, or you'll be involving in the ETL process, or you may be involving in the reporting, in creating reports and doing analysis part. So when we are talking about data warehousing, these are the three roles, these are the three major roles which we are going to involve in. The first one is modeling, and the second area, it's ETL process, and the third area is it's reporting. So when we are talking about data warehousing, your data warehousing system should be capable of doing all these three things. It should be capable of designing a data model, and it should be capable of doing the ETL process, which is nothing but loading data from source system to target system, and it should be capable of performing reports. So these are the three main tasks which data warehousing, which usually we will be doing in a data warehousing project. And when we are talking about modeling, there are many modeling tools which are available in the market. One such modeling tool is, say, Erwin. This is one of the modeling tool which is available in the market. And when it comes to ETL process, there are many ETL tools. Again, there are many ETL tools available in the market. If you, I'm just giving you the major ETL tools, which most of the time, most of the companies which they are using these major ETL tools. One such ETL tool we have is Informatica. This is one of the ETL tool, and again we have a major ETL tool called Data Stage. Like this, there are many ETL tools which are available in the market to do ETL process. And when it comes to reporting, again there are many reporting tools which are available in the market. So one such reporting tool we have is a Business Objects. Then we have IBM Cognos. This is again another reporting tool, and even if you take a Tableau, this is again another reporting tool. So there are many reporting tools which are available in the market. So when we are talking about SAP BW system, why are we discussing about modeling, ETL process and reporting is, your BW, SAP BW is the only module which does all the three things. Using your SAP BW system, you can do the data modeling, you can do the ETL process, and also you can do the reporting. So your SAP BW system is a single data warehousing component which performs all the three things: modeling, ETL, as well as reporting. But if you go for an individual tools, like say suppose there's an organization or there's a company, for modeling they are using Erwin, and for ETL process say they're using Informatica, and for reporting process say they're using Cognos. So it's like they're using three different products for modeling, ETL, as well as reporting. But your BW, SAP BW is the only product which does all the three things. So you, for modeling, you can use BW. For ETL, you can use BW. And for reporting, you can use BW. So that is the reason SAP BW has become so popular. So you don't need to go for a third-party modeling tool or third-party ETL tool or even third-party reporting tool. Everything is there in your BW system. So that is the reason SAP BW module or SAP BW product, it is the only solution for all the three things: modeling, ETL, as well as reporting. And when we are talking about SAP BW system, the source systems for SAP BW will be, most of the time, it will be SAP source. So when I'm talking about source system, particularly for BW, it will be SAP source. The SAP source, usually we call it as SAP ECC system. For SAP source, when we are talking about ECC system, it's nothing but your SAP source. ECC stands for Enterprise Central Component. Enterprise Central Component. This is your ECC. And in ECC, of course, we have different versions, but your ECC is the source system for SAP BW most of the time. And this ECC system, in this ECC system, we have 4 major applications. In this ECC system, we have 4 major applications. So what are the 4 major applications we have in ECC? See, these are the 4. One is logistics. This is one of the major application in ECC system. The next one is financials. This is again one of the major application in ECC system. Then we have HR, that is human resources. This is again one of the major application. Then we have there's one more major applications. As of now, I couldn't be able to recollect. So we have logistics, we have financials, we have HR, then we have industry specific. Fourth one is industry specific. These are the 4 major applications your ECC system contains: logistics modules, financial modules, HR module, even industry specific. When I'm talking about logistics, in logistics, again, we have different modules in logistics. Usually in SAP, there are different logistic modules, like we have one of the logistics module is SAP SD. SD stands for sales and distribution. And again, within logistics, we have something called material management. And within logistics, we have something called PM, plant maintenance. Like this, there are many logistics modules which are available in your ECC system. And when I'm talking about financials, in SAP, we have 2 different modules. One is FI, that is financials, and the other one is controlling, CO. So people like who are from finance background, they may be working with this financial application. So one is FI and the other one is controlling. HR is same, human resources. People from HR background, they can be work on this SAP HR module. And when it comes to industry specific, your SAP supports almost all the industries. For example, when I'm talking about industry, it can be your retail industry, or it can be your banking industry, it can be your, say, real estate. So like this, SAP supports all the industries. And 70% of your, when it comes to ERP market, 70% of the stake goes to SAP, because SAP is having a very big ERP modules. So that is the reason most of the time, whatever the data we want to load it into a data warehouse, that is SAP BW system, we will be loading it from SAP ECC. Your SAP ECC is nothing but it's a source system of SAP. Now to load this data from ECC to SAP BW system, so say this is your SAP BW system. So it's nothing but your data warehouse. SAP BW is nothing but your data warehouse. So the same modeling, whatever the modeling you want to do, the same modeling can be done in your BW system by use for the data from ECC, that is the source system. And you can even perform the ETL process and also reporting. And your SAP BW system has everything internally. Like you have an internal modeling tool, you have an internal ETL tool as well as a reporting tool. When we are talking about reporting tool in SAP BW system, there is something called Business Explorer. This is a reporting tool. Business Explorer is a reporting tool in SAP. In short form, usually they call it as BEX. So in business objects, when we try to create OLAP universes, so all these OLAP universes can be accessed by using your SAP BW system. And when we want to create BEX queries, usually BEX queries are nothing but whatever the queries you have created in your BW system, those when you are trying to access those queries, we call them as a BEX queries. So all these BEX queries can be accessed from your business objects reporting tool. So in order to understand this SAP BW system, how the modeling will be designed, in your SAP BW system, we need to understand BW extended star schema. Just now we have seen what is a star schema. Your star schema consists of dimensions and fact table. But in SAP BW system, we won't be using star schema. Rather, we will be focusing on BW extended star schema.
Hey there! Ready to dive into the world of SAP BOB i4.2? Our course page is here to guide you through. In this course, you will master SAP BOB i4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BOB i4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
So when I'm talking about BW extended star schema, it is just an extension to your existing star schema. This is the existing star schema. Say you have the dimension tables and you have a fact table. This is your star schema. So let me say this is dimension 1, then dimension 2, dimension 3. And this is your fact table. This is a star schema. In star schema, what happens? All these dimension tables are connected to your fact table. In star schema model, all the dimension tables are connected to the fact table, and all your key figures or all your business measures and foreign keys are available in your fact table. This is your star schema model. So SAP, what it does is, it has made some extension to this existing star schema model. So when I'm talking about BW extended star schema, it will be almost similar to your snowflake schema. Most of the time, many were aware about snowflake schema. So here when I'm talking about BW extended star schema, say the first dimension, I'll name it as say product dimension, that is dimension 1. Now in extended star schema, what happens is, first you'll have an SID key. This is your SID, and then all your master data will be maintained separately. So when I'm talking about master data in BW system, we have 3 different master data tables. First one is, we call it as attribute, master data attribute table. And the next one, we call it as master data text table. And the third one, it is master data hierarchy table. Master data hierarchy tables. Usually in your star schema model, what we have seen is all your dimension table contains static data. So when we are talking about static data, it is nothing but the data which doesn't change very frequently. Means it's your master data. But in your SAP BW system, all the master data will be maintained outside your star schema model. See, this entire thing is your star schema model. This is your star schema model. So in star schema model, your dimension tables contain static data. But in extended BW extended star schema, what happens is all the master data information is maintained outside the star schema. And when we are maintaining master data information outside the star schema, it contains in three different tables. One is your attribute table, other one is your text table. When I'm talking about attribute table, it's nothing but this attribute table stores the descriptive information. The descriptive information. And when I'm talking about text, master data text, usually it stores language information. When I'm talking about master data text, it stores a language information. And when I'm talking about hierarchy, this information is used for analysis. Hierarchy from one level to another levels. So your master data contains three different tables: attribute, text, and hierarchies. All these three master data tables are maintained outside the schema. But to connect to these three master data tables from your star schema model, these master data tables are connected via SID. See, SID, then from SID to master data attribute, SID to master data text, then SID to master data hierarchy. So SID is nothing but it's your surrogate ID. So your master data is connected to your star schema model via SID, surrogate ID. So for each and every dimension table, you'll maintain the master data separately. The first dimension table, we thought it as a product dimension table. If you take a second dimension table, for example, let us say this is a store dimension table. So again, for the store dimension table, you'll have an SID, and again you'll have all the three master data tables. One is master data attribute, then master data text, then master data hierarchy. So first one is attribute, next one is text, and the third one is hierarchy. Again, your store dimension will be connected to this master data tables via SID, attributes, text, then hierarchy. So your extended star schema is nothing but whatever the star schema model we have, to that existing star schema model, what they have done is all the master data information they have moved to a separate tables in the form of attributes, text, and hierarchy. And within the dimension tables, they were just maintaining the keys and the facts. So your fact table contains business measures. And this star schema, in BW terminology, we call it as info cube. So this star schema in BW terminology, we call it as info cube. So always remember, your info cube is nothing but your dimension table and fact table. So in BW terminology, we call, instead of star schema model, we call them as an info cube. So an info cube is one of the primary target in SAP BW system, wherein you can create queries on top of this info cube, and these queries can be used in your business objects reporting. For example, say this is your info cube, and this is your, say, business objects reporting tool. SAP BO BI. This is your business objects reporting tool. Now, using this BO reporting tool, if at all I want to write queries by accessing InfoCube, I cannot directly access my InfoCube here. From SAP BO system, this is my InfoCube. I cannot directly access my InfoCube. Rather, what I can do is, on top of this InfoCube, we will be creating BEX queries. On top of this InfoCubes, we will be creating BEX queries. And from your business objects, via this BEX queries, you can access this InfoCube. That is how we will be doing. But if at all you want to design a universe, if at all you want to design an OLAP universe, in that case, again you have a connection, OLAP connection. Using the OLAP connection, you can directly connect to your InfoCube. So your InfoCube is the primary target in your SAP BW system. Then another target we have is even master data. This is, again, we call it as another target. Master data attributes, text and hierarchies. Apart from InfoCube and master data, we have something called DSO. Yesterday we were discussing something about ODS. So ODS is nothing but your, in BW system, we call it as data store object, DSO. So ODS object is nothing but data store object. So you can even perform reports on top of this DSO. But again, in order to connect to your DSO or ODS from your SAP BO system, you require a BEX query. So it looks like this. For example, select. I'm just taking a new slide. This is your extended star schema model. Before going to the new slide, I'm just giving again I'm giving you a recap on this. Your star schema is nothing but your InfoCube, and in your SAP BW system, it has master data tables, consists of three. One is attribute, text, and hierarchy. And these master data tables are connected to your InfoCube. InfoCube is nothing but your dimension tables and fact table via surrogate ID. And you can perform reports via BEX queries from your InfoCube. So you can connect to your InfoCube via BEX queries, or you can create reports to your DSO, data store objects, by using BEX queries. So the flow will be like this. So this is your SAP ECC system. There is nothing but the source system, and from ECC system, the data first it will be moved to a staging area. Usually we call it as PSA, persistent staging area. And from persistent staging area, the data will be loaded to DSO. From persistent staging area, the data will be loaded to DSO. So this is your DSO. From DSO, finally, it will be loaded into InfoCube. This is your InfoCube. This is how the flow goes. So from ECC system, staging area, from staging area, data store object or ODS. Your data store object can also be called as ODS. wherein it contains a detailed information. That's what we have seen in the previous session. Your ODS contains a detailed level of information, whereas your InfoCube contains, this is your InfoCube, it contains a summarized information. Your InfoCube contains a summarized information, and your ODS or DSO contains detailed level of information. Now, if at all you want to access this InfoCube using your reporting tool, say this is the reporting tool, that is SAP BO. You need to access via BEX query. So on top of this InfoCube, we will be creating BEX queries. So you can access your InfoCube from SAP Business Object System via BEX queries. So this is the complete flow. So as of now, why we are discussing about SAP BW system is we want to know this part as well. Usually when we are learning SAP BO BI, actually we are learning this part. SAP BO BI 4.2. So we are learning SAP BI BO 4.2. This is a reporting tool. But before reporting tool, we want to see how the data will be loaded from ECC system to the target. There is nothing but InfoCube, and how to create queries on top of this InfoCube by using Business Explorer. And we can also create reports on top of non-SAP data sources. When we are talking about non-SAP data sources, it can be anything. It can be your Oracle or so when we are talking about non-SAP data source, so it can be Oracle or it can be your MS SQL Server, anything. It can be your Sybase, anything. But for your non-SAP data sources, what we need to do is we need to design universe. We need to design a universe. All the universes will be designed by using IDT in your SAP business objects. We have two different universe designing tools. One is UDT and the other one is IDT, but most of the time we will be using IDT. Of course, I'll show you an overview of how to create a universe in UDT as well, but most of the time we will be using IDT to design our universe. So this universe can be designed by using IDT. So from your SAP business objects, you will connect to IDT. From IDT, using drivers, you can connect to any of these non-SAP data sources. So this universe, we call it as a relational universe, because whatever the data we are using, as a source, it's a relational databases. Like it can be your Oracle, SQL Server, MS Access, anything. So this we call it as a relational universe. If at all you're trying to create a universe on top of say OLAP databases, and when I say OLAP databases, your InfoCube, again it's a OLAP database. So this universe, if at all you want to design a universe on top of InfoCube, this we call it as OLAP universe. OLAP universe. For OLAP universe, again you no need to do any modeling and all, because the modeling part has already been designed in SAP BW system. So there is no point again in designing a modeling. The only thing is connect to your SAP BW target. There is nothing but your InfoCube, and create classes and objects. Using these classes and objects, you can create reports. But for non-SAP sources like Oracle, MS SQL Server, you need to create a universe. You need to import the metadata of all these metadata of the tables which are available in your source, and you need to design some schema inside your universe, and you need to make some relationship between those tables, and finally you can access this universe from your business objects and user interface. When we are talking about business objects and user interface, we have something called BI Launchpad. Using your BI Launchpad, you can connect to your universe. So in your BI Launchpad, you have Web Intelligence as well as Crystal Reports. Even you have some other applications as well. So using these applications which are in BI Launchpad, you can access the universe which you have created on top of the non-SAP data sources. That is nothing but either your Oracle or your SQL Server or your MS Access. Now we have seen the start schema, BW extended start schema, and how you can connect to your InfoCube. That is one of the targets in SAP BW system using your reporting tool, that is SAP BO 4.2. But in order to understand your SAP BW system, we need to understand few things. We need to understand a little about ECC system. We need to understand about characteristics and key figures, and there are certain things in SAP BW system. So we are going to see all those things in SAP BW system. Probably we will be spending 2 to 3 sessions on SAP BW system. And when it comes to non-SAP systems, of course, most of you are aware of any of the databases, maybe like Oracle. You might be familiar with Oracle, or you might be familiar with SQL Server. So no need of introducing all these non-SAP data sources. But when it comes to SAP source, I just want to give you an overview of SAP ECC as well as SAP BW system. So to access either your SAP ECC or your SAP BW system, we have an user interface. This user interface, usually we call it as SAP GUI. SAP GUI is one of the user interface in order to access SAP ECC system. If at all I want to access SAP ECC system, what I need to do is I need to log into my SAP GUI. When I'm talking about SAP GUI, I'll just show you an overview how to use the SAP GUI. Whatever I'm connecting now, it's my remote desktop. Of course, you will be having different access. They'll be providing you a remote access as well. In order to access your SAP GUI, you need to do it from your remote desktop. This is my remote desktop. Whatever you see here, this is my remote desktop, and this is my SAP GUI. You can see there's an icon SAP Logon. Sometimes you may not see this icon because by default someone might have deleted this icon. In that case, you can go to Start, All Programs, and SAP Frontend. You can see there's a folder SAP Frontend, and you can connect to SAP Logon. Or if you have the shortcut icon, directly you can double click on SAP Logon pad. In this SAP Logon pad, of course, you can see 3 different applications. We have a SAP BW system, which runs on Oracle database, that is a traditional database. And again, we have SAP BW system, which runs on an in-memory database, that is nothing but HANA. And you can see your source here, SAP ECC EHP 7, Enhancement Pack 7. EHP 7 stands for Enhancement Pack 7. ECC stands for Enterprise Central Component. So in order to access either your ECC system or your BW system, the first thing you need to do is you need to log into your SAP Logon pad. See, this is your ECC system. You can double click on this. It will ask for the username and password. So whatever the credentials they have provided to you, you can use the same credential. This is how your SAP ECC system looks like. See, in this SAP ECC system, you have different applications. Can you see logistics? You have logistics here. In logistics, see, these are so many areas in logistics. Of course, in the paintbrush which I have opened, I have shown you only SAP sales and distribution, SAP material management, few things I have shown you. But there are so many things which are in the logistics applications, and you have accounting, you have human resources, you have even information systems. So when we are talking about information systems, again, this is a separate area. Okay, so your ECC system contains so many applications. That is the reason when we want to load the data into SAP BW system, most of the time, means 99%, the data we will load from SAP ECC system into our BW target. The other 1% it may be from non-SAP data sources. Sometimes it can be even from a flat file, or it can even from some other database. But most of the time, the data which we are going to load into SAP BW system is from ECC. So this is how you will be logging into ECC. Now, if at all you want to know on which version you are running, on which version you are working for ECC, you can go to Systems and Status. You can see the ECC component version here and the underlying database for this. See the product version under SAP System Data. The product version for ECC is, so you'll get the version here somewhere. Okay. Usually we call it as ECC 6. Okay, we call it as ECC 6. And on which database it's running? The underlying database for ECC is Oracle database. So in this example, your ECC system, this is your ECC system. This ECC system runs on Oracle. This ECC system runs on Oracle. And when we are talking about BW system, even for BW system, we will be using the same user interface. You can log off this one. See, this is BW on Oracle as well as BW on HANA. You can take anything. Let me take BW on Oracle. All you need to do is open your SAP GUI, double click on it and provide the username and password. So this is your SAP BW system which runs on Oracle. Let us see the status. Go to System, Status. SAP NetWeaver BW. This is the product version. It is 7.4. That is the version. And the database which runs is Oracle. So again, whatever the info cubes you create here, all these info cubes, the data for all these info cubes are stored in your underlying database. That is nothing but Oracle. So your ECC runs on Oracle as well as your BW also runs on Oracle. So in a coming session, what we are going to see is, we want to, before loading the data from SAP ECC system to InfoCube, so we will be seeing three things. In SAP Introduction to SAP BW system, we will be seeing how to do the modeling part. I'll show you how to create all these info cubes and DSOs, all these things. So probably we will be seeing two targets. One is we will be seeing how to create an info cube and how to create ODS or DSO. Then after doing the modeling, I'll show you how to load the data from ECC system into a BW system, or I'll show you how to load the data even from a non-SAP. For example, when I'm talking about non-SAP, it can be a flat file as well. So I'll show you how to load data from ECC, that is your SAP source, and also from flat file. So we will be seeing from both. Then after creating DSO info cubes and loading data into these targets by using ETL process, so we will be doing the modeling part and also the ETL part. Then I'll show you how to create queries on top of these two targets, InfoCube as well as DSO, by using a reporting tool called as Business Explorer. So these are the things which we are going to see in the next session. So in the next session, we are going to design a model of InfoCube. But before designing a model of InfoCubes, there will be few terminologies which will be very new to you, like info objects, data sources, info sources. There are certain new terminology which we will be using in the coming session, but it's okay. It's easy only. It's nothing tough. All you need to understand is how to move the data from ECC source to SAP BW target. So once you understand that, then we start creating queries on top of SAP BW target. And when it comes to non-SAP sources, of course, most of us are familiar with non-SAP sources. Directly we can connect to non-SAP sources by using SAP business objects. So why I want to spend little time on creating modeling, ETL and reporting on top of BW system is you can even when you try with business objects later on when you apply for jobs, you can even show that you're familiar in creating reports both with SAP sources as well as non-SAP sources.
You said that the master data, and usually in star schema, you said the master data is saved in the dimension tables. But
yeah, in star schema,
but in extended star schema or snowflake schema, it is stored in your other tables, like master, attributes, text and everything.
Yes.
And those are connected through some SID, which I'm believing something is system generated.
Okay, yeah. The SID is nothing but something a system will be generated automatically.
Right. And so you are saying that the dimension tables in the extended star schema will have only SIDs?
The dimension tables in the extended star schema contains your primary keys as well as little descriptive information, not only SID.
Oh.
See, SID is nothing but in order to, just for example, say there is an employer, okay? So he is working for a project XYZ. He worked in that project for XYZ for 1 year. Let us say in that XYZ project he worked for 1 year. After 1 year, in the same company, say he has been moved to a different project. Now again, a different SID will be generated for the same employee. Okay. So your SID is nothing but how many times this employee has been, in how many projects this employee has been worked in the same organization. It gives you all the details of this employee. So each and every time it generates a key. For example, if you take in a normal data warehousing project, you have something called there's some option like we have 3 areas like SCD1 something and all in normal data warehousing projects, slowly changing dimensions. Hope you are aware about slowly changing dimensions. In slowly changing dimensions, what happens? Usually when the employee say worked for 1 year in one project, later on he has been moved to another project, again a different key will be generated for this employee. So your SID is similar to that. So every time when a change takes place, it will generate a new key. Every time when a change takes place, it will generate a new key. So if at all you want to know more clarity on this, again in the tomorrow session, of course, there is a PPT for that. Today I couldn't able to locate the PPT in the material tab. That is the reason I have used paintbrush. So I'll show you the BW extended star schema diagram once again. And in that PPT, it's clearly mentioned like how the data has been moved from dimension to master data tables. Okay, so in the next session, again, like we will be discussing this. That's not a problem. Okay, to have a better understanding. Today I couldn't able to locate that PPT, so that's the reason I have used the paintbrush. Whatever the cube we are talking is, your cube is a target. And when we are talking about source, it's Oracle or HANA. Yes, it's same. The only thing is, if you're using Oracle as a database, the information in the cube or the data in the cube will be stored in your Oracle database. If you're using HANA as a, InfoCube concept, same. Okay. He's asking whether it's in, InfoCube, no. InfoCube concept is little different in HANA when it comes to Oracle. Okay. See, like when we are creating InfoCube, most of the time we will be using Oracle as a database. But when you're using the creation of InfoCube in HANA, whatever the info cube you're creating in HANA, this info cube, we need to make this info cube optimized in the HANA database. So little additional steps are required. It's not the same concept. Little additional steps are required in order to create a cube on top of HANA database.
In case of source system as non-SAP ECC, like just Oracle or something. So you are saying you are going to create universe using IDT or UDT, which is older version, and try to connect SAP BO, BI 4.2 with it, okay, and create reports, right? So there is nothing mention of info cube or something, right? This is just a ER.
See, like when we're talking about non-SAP, it's only an ER.
Yeah, right. So info cube is only related to when you're talking about the SAP ECC part of it, right?
Info cube is related to SAP BW system, the target.
BW, yeah, exactly, the target. And the BEX queries is also related when you want to extract or run queries over the info cube, right? SAP BW only.
Yes, even the BEX queries are related to SAP BW.
So on the slide which you are showing right now, you have mentioned OLAP universe. So is that something which you are creating it through IDT or something, or is that something different?
No. So when I'm talking about OLAP universe, it's through IDT. Okay. Through IDT, I can directly connect to my info cube. Okay. So in that case, this BEX query will not come into picture. Case, okay. This one will not come into picture from this when I'm talking about OLAP universe, even this OLAP universe will be created in IDT. Okay. So even this one will be created in IDT. So in order to create this universe from your IDT, I'll directly connect to my info cube. I won't be using the BEX queries in between. Okay. We will be seeing both a relational universe as well as OLAP universe as well. But to understand OLAP universe, I thought of like telling you a detail on how to create this OLAP databases. That's nothing but your info cube.
Hey there! Ready to dive into the world of SAP BOBI 4.2? Our course page is here to guide you through. In this course, you will master SAP BOBI 4.2. Your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget-friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BOBI 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
See, actually, this is your SAP BW landscape. Whatever the slide I'm showing you, the name of this slide is SAP BW and the source systems. Now, all the source systems you can see at the bottom of this slide. You can see different source systems here. You can see an SAP sources like R/3, and you can see a non-SAP source like flat file. And again, you can see a non-SAP sources like relational database management system. You can even see other non-SAP sources like legacy systems as well as different data providers. So these are all will act as a source system for a SAP BW target. Now, above your source system, you can see there is something called SAP BW server, which is on your right hand side of this screen. There's some background noise. I request you to please mute your mic. If you have any questions, you can use the chat box, but please make sure you mute the mic so that there won't be any background noise. Now, above your source systems, you can see there's a BIW servers, and the BIW server, you can see three main areas. One is your metadata repository. This is the first one. And the next one is your different processors as well as engines. That is your second area. And on your right hand side, you can see an info cube as well as ODS. These are the different targets which we are going to create in the SAP BW system. So all these things are available above your source systems. This we usually call it as an application layer. The below one, the bottom one, we call it as a database layer, and above one is an application layer. And above application layer, we have a presentation layer. When we are talking about presentation layer, we have both a Business Explorer. You can see above the first one, Business Explorer. This is nothing but a reporting tool. It's an inbuilt reporting tool in SAP system. Your Business Explorer can also be called as BEX in a shortened form. And not only Business Explorer, you can even use a third-party reporting tools. That's what you can see in this diagram, which is on right hand side. That is above your info cube. You can see third-party OLAP client. When we are talking about third-party OLAP client, it can be a different reporting tool. Mostly it can be a business objects, because even business objects is a reporting tool from SAP. So when we are learning SAP BO BI, we will be seeing both the reporting tools along with the business objects BO BI 4.2. We will also see an overview of the internal reporting tool of SAP BW system, that is nothing but Business Explorer. Now moving to the next slide, the same architecture but a little detailed way. You can see all the source systems at the bottom of the slide, and above that you can see the application layer. Inside application layer you can see two types of data here. One is a master data, and on your right hand side you can see transaction data. So when we are talking about master data, in my previous session, as I told you, all the master data will be maintained outside the star schema model in three different tables. That's what we have discussed in the previous session. When we are talking about three different tables to maintain master data, they are attribute table, text table, as well as hierarchy table. These are the three different tables wherein we store master data information. And when we are talking about transaction data, your transaction data is available in the targets such as InfoCube and ODS. This application layer, you can see a reporting layer, which contains DAX analyzer, web applications, even mobile intelligence. So this reporting layer, whatever you see in this slide, it is a reporting layer for SAP BW system. But along with this reporting layer, we will also using the business objects reporting layer as well. This is the complete BW system architecture. In this BW system architecture, you can see an SAP source as well as non-SAP source. At the bottom of this slide, you can see an SAP source as well as non-SAP source. When we are talking about SAP source, you can see it on your right hand side, that is R3 OLTP applications. And if it's an SAP source, the user interface is different. Okay, here it says ALE/TRFC. Of course, we are not very much focused on these things because automatically it comes. And if it's a non-SAP source, the interface is BAPI, Business Applications Programming Interface. So we won't bother about the source system because the source is already available to us in the form of SAP source or non-SAP source. The only thing we are concentrating is we want to see how to load the data from source into BW system. And in the application layer, you can see the complete BW system here. You have a staging engine, you have a metadata manager, you have OLAP processor, and on your right hand side you can see different objects here. You have ODS, that is operational data store, or DSO. You have an info cube, you have info object catalog. So all these things are available in your BW system. And on your left hand side, you can see something called administration workbench. In this administration workbench or data warehousing workbench, you can do all the administration part. You can even schedule the loads, and whatever the loads you have scheduled and whatever the loads are processing, you can even monitor the loads. So all these things can be done in your administration workbench or in your data warehouse workbench. And above this, you can see a reporting layer, that is your Business Explorer as well as third-party OLAP clients. The same information, it has been presented in different formats. We have a database layer, we have an application layer, and then we have a presentation layer. Now, special features in this BW architecture, either we can have a BW as a single source, or it can also be as a multiple source. Of course, we don't require all these things because for us, your BW system is a single source. That is what we are going to use in our reporting part. This is where the modeling comes. Star schema model already we have discussed star schema model in a previous session. And when it comes to BW extended star schema, this is what we are going to see now. Star schema model we have already discussed. Now we were about to discuss this extended star schema model. In extended star schema model, on your left hand side you can see the fact table as well as dimensions. You can see the facts like customer dimension, you can see customer number as well as area, and the product dimension you can see material number. And this information, the one which is in blue color, this is nothing but your star schema. Now in extended star schema, what happens? The master data is maintained outside this star schema in the form of three tables. You can see all the three tables here: customer attribute table as well as sales hierarchy and text table. Means here you can see attribute table, hierarchy table as well as text table. Okay, you can see the master data information has maintained in three separate tables: attribute, hierarchy as well as. So this is extended star schema. Now going further in extended star schema, this is how your extended star schema will look like. The one which you see, the central one, the center one which you see is a star schema. You can see a fact table, and this fact table is connected to different dimension table. This is nothing but your star schema model. And outside this star schema, you can see all the master data tables are connected to. Outside the star schema, you can see all the master data tables are internally connected with SID. That's what we have seen in the previous session. So if at all I want to connect to my master data tables from my star schema via SID, I can connect to my master data tables. You can see SIDs here, which is in green color. And this SID, again, it's getting connected to master data attribute, then text as well as hierarchies. So likewise, your each and every dimension, whatever the master data information available in each and every dimension, this master data information can be maintained outside the star schema model. That is what the advantage of extended star schema. Now going further to the next slide, we need to know something about dimension tables and fact tables in BW system. When we are talking about BW system model, a minimum of 4 dimensions can be created for a BW system, a minimum. So when we are talking about the minimum 4 dimension IDs, it will be your time dimension, unit dimension. You can see here within the brackets, you can see the minimum 4 dimensions include time, unit, data package as well as one custom dimension. Means in this minimum of 4 dimension IDs, you can create only one custom dimension ID, and the remaining 3, time, unit and data packet, all the remaining 3 dimensions are by default and you cannot customize them. only one dimension can be customized out of the minimum 4-dimension IDs which we can create for an extended star schema model in SAP BW system. So always remember minimum of 4-dimension IDs. And the maximum is 16. So when we are talking about maximum 16 dimensions, it includes even the 3 default dimensions. You can see here in the brackets, you can see including time, unit, data package, and 13 custom. So maximum out of 16 dimensions, 13 dimensions can be customized, whereas the remaining 3 dimensions are used as a default. And all these dimensions can have characteristics of 248 characteristics. That is one, the maximum characteristics. And in dimension tables, these are the data types which we are going to use. When we are creating attributes in a dimension table, these are the data types we can use. We have 4 data types. One is CHAR, other one is NUMC, then DATS, and then TIMS data types. So these are the 4 data types which we are going to use while creating dimension tables in SAP BW system. And when it comes to fact tables in BW system, a maximum of the 233 key figures can be created for one fact table. You can see here the first. Under fact tables, the first bullet point says a maximum of 233 key figures. You can see here. And the second point, it says dimension table and fact table are linked by dimension IDs internally. That's what we have seen in the previous session. Your dimension table and fact table both are connected internally by using IDs, dimension IDs. And your info cube is linked to master data by SID. That's what we see here. See the complete the circle, whatever you see inside the circle, it's an info cube. That's nothing but your star schema. So when we are talking about info cube in BW system, your info cube contains what? Dimension table as well as fact table. And this info cube is connected to the master data tables. We can see 3 master data tables here. We have master data attribute, text, and hierarchy. So this info cube is connected to the 3 master data tables via SID table. That's what the point says here. Info cube is linked to master data by SID. Now going to the next slide. This is how your extended star schema model diagram looks like. You can see an info cube here. If you notice properly, you can see an info cube which is highlighted inside the box. This one square box which is highlighted inside this box. You can see different dimension tables here. You can see sales organization dimension. You can see a customer dimension. Then on your right hand side you can see time dimension. You can see material dimension. And all these dimension tables are connected to the fact table. You can see the fact table is the center, which contains all the IDs, material, sales ORG, time, as well as customer. And below this IDs, you can see key figures or business measurements in the form of sales amount as well as quantity. So this is your star schema. And in your extended star schema model, all the master data is maintained outside the star schema. So that is the reason, if you notice here for material dimension, you can see a master data attribute table, then you can see a text table, then a hierarchy table. So in this master data dimension, you can see all the 3 master data tables, attribute, text, as well as hierarchies. So this is how your extended star schema model looks like. So when we are talking about star schema model, we will be using info cube as well as we will be using info cube. When we want to load the data into star schema model, we will be using info cube. When we want to load master data, because in the previous slide we have seen there are 2 types of data. One is master data and the other one is transaction data. all your transaction data will be loaded into the info cube, the one which you see here in the middle, in the center of this slide. And all the master data information will be stored into 3 different master data tables, that is attributes, text, and hierarchies. Now going further, the same information they have explained it in a detailed way. If you notice here, this is the info cube. Whatever you see here is the info cube, and this info cube contains, you can see here, a customer dimension. How can we differentiate the attributes as master data attributes and text? Okay, see, that's what, when we are talking about master data attributes, in your customer dimension, the attribute information I can say as customer name, customer address, all these things I can call it as a master data attribute. And when it comes to text, usually your master data text, it stores language information. So your master data text stores language information. So whenever there is a language information, this language information will be stored in a text table. Whenever there is a characteristic information or master data attribute information, this will be stored in your attribute table. Now in this slide, we can see, thank you. Okay, welcome on. In this slide, we can see customer dimension, all the 3 dimensions, materials, as well as time. So all these 3 dimension tables are connected to the fact table. In the center, you can see the fact table. It contains the keys as well as the facts or business measurements. So when we are loading data into InfoCube, this is how we will load the data into different dimension tables and fact table. But whatever the data we are loading into InfoCube, it's a transaction data. Because for master data, again we have a separate tables. Above InfoCube or above your star schema model, now you can see the master data information. In this master data information, see, for example, they have taken for customer. On your left hand side, whatever the box you see here for master data, you can see the customer number, city, as well as industry. So this is your master data attribute table. And on your right hand side, you can see a hierarchy table. When we are talking about hierarchy, it can be of different regional hierarchy. Say, I want to know the south, the region south, or I want to know north. So hierarchy, which is particularly used for, in the later point of time, it's used for analysis. But here in this slide, you cannot see master data text information, because usually a master data text table, it stores language information. Of course, in this slide, you are unable to see that.
Hey there! Ready to dive into the world of SAP BO I 4.2? Our course page is here to guide you through. In this course, you will master SAP BO I 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO I 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
So whatever we have seen till now, it is just an overview of SAP BW system. Like your SAP BW system contains, the architecture contains a data type, that is nothing but it can be a non-SAP source as well as SAP source, and above that we have an application type. In your application type, we have all the different targets, like we have InfoCube, we have ODS, we have metadata, we even have info objects, catalogs, all these things in the application type. And above that we have front end, that is nothing but a presentation layer. In presentation layer, we have seen 2 different reporting tools. One is the internal reporting tool of SAP BW system, that is nothing but BEX Business Explorer, and the other one is third-party reporting tool. When we are talking about third-party reporting tool, that is where your business objects comes into picture. Now from here we are going to see the data modeling part in your SAP BW system, because in my previous sessions, as I told you, if at all we want to perform a data warehousing, if at all we want to implement a data warehousing project, we need to be familiar with three main areas. One is the modeling, that is the first thing. So your SAP BW system even supports modeling. So you can even do the modeling part by using SAP BW system. And the next one is ETL part or ETL process, extraction, transformation and loading. Even with your SAP BW system, you can do the internal ETL process. And when it comes to reporting, with SAP BW system, we have an internal reporting tool called as Business Explorer. So all the three tasks, you can do it in a single module. You can do a modeling, you can do the ETL process, as well as you can do the reporting. Whereas if you see other ETL tools, like we have an Informatica or Data Stage, either they only perform the ETL process. Again, for reporting, you need to go for a different reporting tools like Cognos or Tableau or whatever it is. When it comes to modeling, again, we need to go for a different modeling tools, like one of the modeling tools we have is Airway. So these are three different tools, like for modeling one tool, for ETL another tool, for reporting again another tool. But in SAP BW system, it's not like that. All the three, modeling, ETL as well as reporting, can be done by using this module SAP BW. So we are starting up with data modeling part in SAP BW system. When it comes to data modeling part, the BW tools, or you can say the business warehouse tools we have is, the first one is the workbench, administration workbench. So using this administration workbench or data warehousing workbench, this is also in the latest versions, it is also called as data warehouse workbench. Using this workbench, we will be doing the modeling part as well as we will be doing the ETL process using administration workbench or data warehouse workbench. This can be used to do modeling as well as ETL. And below administration workbench, you can see different areas of reportings. You can see a Business Explorer Analyzer. You can see a Business Explorer Browser as well as Business Explorer Maps. So all these three tools together contribute to the reporting part of your SAP BW system. So using your administration workbench or DWH workbench, data warehouse workbench, you can perform modeling and ETL. And using your Business Explorer, you can perform the reporting part. So let us start up with the administration workbench, wherein you can do the modeling as well as ETL process. So in your administration workbench, we have different components. So before discussing the components, see the definition says the administration workbench is the tool which is used for controlling, monitoring, and maintaining all of the processes. So using this DWH workbench or administration workbench, it is used to control, monitor, and maintain all of the processes connected with data staging and processing in the business warehouse. So using your administration workbench, we can perform three things. One is controlling, other one is monitoring, and the third one is maintaining. All these processes can be done by using data warehouse workbench or administration workbench. And in this administration workbench, we have different components. Below you can see the components here, all the components. We have modeling component, we have reporting agent, monitoring, transport, connection, business content, translation, and metadata repository. See, these are the different components available in data warehouse workbench or administration workbench. Let us see one by one. First, if you go for the modeling part, before going to the modeling part, they have given an overview of administration workbench. See, your administration workbench, it looks something like this. We need to log into SAP BW system. As in my previous session, as I told you, the user interface to access SAP system is SAP GUI. That is nothing but your SAP logon pad. So this is your SAP logon pad. You can see here SAP GUI for Windows. You need to log on to BW system. So we have two BW systems here. One BW system which runs on the traditional database, that is Oracle, and other BW system which runs on an in-memory database, that is HANA. So let me connect to our traditional database, BW and HANA. Double click on that name. The moment you double click on that name, this SAP screen will open for you. Provide the credentials. You will be getting these credentials very soon, the server access. So this is your SAP Easy Access screen. Now, if at all you want to go to the administration workbench or data warehouse workbench, in the latest versions we call them as data warehouse workbench. In SAP, for each and everything, we have a transaction codes in SAP BW system. Each and every screen, we have a transaction code. The transaction code is similar to a name. For example, if at all I want to identify someone, so I will identify that person with a name. The same way, in SAP, if at all you want to open to different screens, if at all you want to work with different areas, for each and every area, you have a transaction code. Usually we call it as a T code. So this T code will directly take you to that particular window. In order to access my administration workbench or DWH workbench, all the transaction codes has to be provided in this box. You can see which is on your left-hand side top. So RSA1, this is the most familiar, most used transaction code. So this is one of the transaction code, RSA1. So you need to provide the transaction code RSA1 in order to go to the administration workbench or data warehouse workbench. You can see above your taskbar, it says if we want to start the documentation. As of now, we don't require any documentation. See here, this is what you can see here. Data warehousing workbench. This is nothing but your administration workbench. And here you can see the modeling part. Okay. So this is how your data warehousing workbench will look like. If at all we want to do all the modeling, we can do it in data warehousing workbench. In this workbench, we can do all the modeling part. Now, going to the slides, we go back to the slides. So this is your administration workbench. What was RSA1? Is it the same to call? What was RSA1? Is it same to call DW workbench? See, RSA1 is the transaction code which is used to call data warehouse workbench screen or data warehouse workbench window. Because in SAP BW system, we have different transaction codes or we have different E codes in order to call different windows. So RSA1 is one of the transaction code which we use frequently while we are working with BW system in order to call DWH workbench. Okay? Okay, welcome. So this is about the same thing you have seen, whatever I have shown you, the same way you can see here. Then moving to the next slide, you can see that the administration workbench or DWH workbench, which is on your left hand side. So whatever we have opened now by using RSA1, this is the one which we have opened. So where we can do the modeling part, we can do the administration part, as well as we can schedule all the data loads, and also we can monitor all the data loads using data warehouse workbench or administration workbench. Now moving to the next slide, your administration workbench. These are the things which you can do using administration workbench or data warehousing workbench. So in my session, I call it as data warehouse workbench instead of administration workbench. So when I'm talking about modeling, you can see it on your left hand side. You can design all the BW models, and later on you can maintenance, and you can even do the administration processes. Like you can even create some process chains and all these things by using modeling. And on your right hand side, you can see the scheduling part. You can schedule all the data transfers as well as loading data into target systems. Or all these things can be done by using data warehouse workbench. And below you can see the monitoring, and the monitoring, you have monitoring data loading processes. You can monitor all the loading processes, as well as you can even monitor update processes. So all these tasks can be performed by using BW, Data Warehouse Workbench. Already we have seen this one in Administration Workbench or Data Warehouse Modeling. We will be doing all the modeling part. To come into this screen, we have a transaction code called RSA1. So RSA1 will directly take you to this screen, whatever the screen you see here. Now the next component in DWH Workbench is monitoring. So when we are talking about monitoring, so it says here, with the monitor you can check the data loading process and data processing in BW and analyze errors. Usually when we are doing the ETL process and the loads are getting processed and the data is getting processed, we can monitor the loads. Sometimes the loads may fail, or sometimes the loads may stop. We need to resume the load. So all these things can be done by using this monitoring component. And the second bullet point says persistent staging area. So when we are talking about persistent staging area, the data, as I told you in my previous session, from source system, first it goes to PSA. There is a staging area, and from PSA it goes to the ODS or DSO. Then from DSO it goes to InfoCube. That's what I have told you in the previous session. So in a persistent staging area, what it says, the PSA represents the holding area for raw data. You can check the data in PSA and make changes if necessary. So in your PSA, you can make, if at all you want to make necessary changes, you can make necessary changes in your PSA, and from there you can finally load the data into target system. And the third bullet point we can see here is info package group. So with the help of this group, you can allocate data requests that logically belong together and schedule them using the scheduler. Usually this info package group is used to schedule all the loads. Of course, we are going to see all these things. We are going to see the persistent staging area. We are going to see the info package, everything. This is about the second component, monitoring. So the main purpose of monitoring is you can check the data load process and data processing in BW system and analyze if any errors occur. This is how your monitoring screen will look like. But see here, if you have noticed here, we are in the same administration workbench. But instead of modeling, it's displaying here monitoring. Okay, so that is the reason I told you, most of the time, we will be using the T code RSA1, the transaction code RSA1. Now reporting agent. The reporting agent, it says the reporting agent is a tool for scheduling reporting functions in the background. And it has two functional areas. One is checking exceptions and other one is printing queries in the background. So usually your reporting agent is used for scheduling reporting functions in the background. So most of the time, like, we won't be involving in this reporting agent. But the purpose of this reporting agent component is it's a tool for scheduling reporting functions in the background. This is how your reporting agent screen will look like. Again, if you have noticed here, we are in the same administration workbench, or we are in the same DWH workbench, data warehouse workbench. Transport connection. If at all we want to transport whatever the models you have created or whatever the things you have created in development system to a testing system, and from testing system or quality system, and from quality system, if at all you want to transport the data of the models into production system, for that purpose we will be using this transport connection. See, that's what it is, using the transport connection. All newly created or changed metadata objects of the BW, Business Information Warehouse, can be collected in the development system. Okay, so whatever you have created newly or whatever the modified things, modified objects you have created in the BW system, okay, are collected in the development system and then transported in connection with the change and transport organizer to a different system. Maybe it can be your quality system, and from quality, in the quality system you will test all the objects whether everything is working fine, and from quality system finally all these objects will be moved to the production system. So these are the three different systems which are in the landscape of SAP BW system. Whatever we see in the remote desktop, that system is a development system. In the development system, we develop different objects, we create different targets. All these things will be developed in the development system. From development system, it will be moved to a quality system for testing, and from quality system, finally, it will be transported to the production system. And the transport connection, we have different versions. So whatever the objects you create, all these objects will be with different versions. The first time when you see any object, that object will be in the form of version D. D is nothing but delivery version. So it's not yet activated. So this object, this delivery version object can be used and later on it can be activated. The first version is delivery version and the next one is modified version. Modified version is nothing but once the object is activated, then you sort of again make some changes to this activated object. That is known as modified object. And activate object is nothing but whatever the delivery version object you have, the D version. If this D version object you want to utilize in your modeling part or in your development part, once you activate, once you save, that will become an active version. Of course, all these things we don't require from a BW system because our main intention is to learn SAP BO BI 4.2. But here we are just seeing an overview of BW system, how the data can be loaded from source to target system. So that we want to use that data which is in BW system for our reporting and queries. So this is how your transportation screen will look like. Then business content. Again, this is of a different area. Wherein most of the time people from SAP background, they require this information. Business content is nothing but it's a predefined business model which comes as an add-on into BW system. When we are talking about predefined business models, already the business model information is available, already the content is available, and if at all you want to use this predefined business model content into your existing development, you can utilize this business content. But to install this business content, we require an add-on license. It doesn't come with the BW system, it comes as an add-on. Even we don't require this one, installing business content. This is for SAP BW consultants. Translating text for BW objects. So again, this talks about the text information. Okay. For example, if you take a product, each and every product has a text information. Sometimes the text can be in different languages other than English. It can be in German, or it can be in Japanese, or it can be in China. So all this text information from English, it can be translated into different languages. Even we are not going to see the translation information because whatever the language we have is, the default is English. So these are all the things for SAP BW consultant. So these are the different components available in SAP BW system. And metadata repository. So when we are talking about metadata repository, you can see few points here. It's a HTML based BW metadata repository. So all your metadata information is available as a browser, and you can access the information on BW metadata as well as most important properties of the objects and links to other objects. So your metadata repository contains information of other objects, properties, and information of other objects, and also links to other objects. Different links are available in this metadata repository, and this metadata repository is available in the form of browser, HTML based. The third bullet point says you can search and exchange metadata, export HTML pages, and display the graphics of the objects. So all this information can be done by using metadata repository. We are not going to touch this metadata repository. All we want to see the modeling part as well as the ETL part and a little BW reporting by using BEX. So these are the areas which we want to concentrate from SAP BW system, because we don't want to learn the complete BW system. So these are the different components available in your data warehouse workbench. Now this one is required for us, because if at all you want to do the modeling part, you require the different modeling functions. In SAP BW system, we have different modeling functions. These are the different modeling functions. The first one we have is info objects. So when I'm talking about info objects, what is an info object? Here it says, the first bullet point says it's the basic building blocks for BW. So info object is nothing but, in general, it's nothing but a table. You're going to create a table. And the second bullet point says info object is the generic term for business evaluation objects such as customer, product, region, etc. So if you take this in database terminology, you can say it's a customer table, product table, region table, as well as revenue table. But in BW terminology, instead of table, we call it as an info object. And for your table contains a name. For each and every table, you will have a name. The same way, if you notice the third bullet point, it says an info object carry the technical definition as well as a business logic that are used across the whole BW system. So when you're creating an info object, or the database terminology, when you're creating a table, for this table usually you will provide the table name and description. The same way, for your info object, you will provide the technical name as well as business logic, and these two things are used across the whole BW system. Means whenever you want to call the table, whenever you want to use the table, by using the technical name or by using the business logic, you can search for the table. The info object in BW terminology is an info object, but in database we call it as a table. So the info object is nothing but, you can see the example here. It's a customer info object, product info object, region, as well as revenue info object. So this is the first modeling function, info objects. You can see info objects here, the diagram. In the center you can see the info objects. These info objects can be utilized in your info cubes, in your ODS. This is again one of the target. Even in your master data tables like attribute, text and hierarchy, and also in your ESA tables. So these things, for example, if I say customer ID or customer name or material description, these are all the info objects. So all these things can be used in different areas of your BW system. You can use them in your info cube, you can use them in your ODS object, you can use in the master data tables, and also you can utilize them in your ESA tables. So this is your info object. Now going to the next slide. In info objects, we have two types. Just if you take a table, customer table contains a characteristic information as well as a numeric information. For example, in a customer table, you can have a customer ID, name, address, and customer income. Customer name, ID, and address, we call it as a characteristic information or characteristic columns. Whereas customer income, you can call it as a numeric column. The same way, here in your info objects, you have two types of info objects. One is a characteristic info object, the one is key figure info object. When we are talking about characteristic information, characteristic info object, It's a descriptive information. If you take a customer table, the descriptive information for customer table is customer ID, name, address. Okay, these are the characteristics. And when we are talking about key figures, it's a quantitative information which can be measured or which can be calculated. Key figures are nothing but your business measures. In BW terminology, for business measures, we call them as key figures. So in this example, we can say, in the customer example, we can say salary as the key figures and customer ID, name and address as characteristics. So your info object contains two types, characteristics and key figures. You can see here in this administration workbench modeling. On your left hand side, on the modeling box, in the navigator, you can see below info provider, you can see an info object which is highlighted here, info object. So when we are talking about info object, it contains two types of info objects. One is characteristic info objects and the other one is key figure info objects. Characteristic info object contains descriptive, whereas key figure info object contains quantitative. That's what they have given here. Types of info objects, characteristics. Characteristics are business evaluation groups like cost center, product group, material. So all this information comes under characteristics. Whereas key figure of an info object form the data part. Key figures can be quantities, amounts or number of items. The same thing. So always remember your info object contains two types, characteristics and key figures, because we're going to create an info objects in BW system. We're going to, in order to model a info cube or in order to design a star schema model or extended star schema model, we need this info objects. So info objects has characteristics as well as key figures. In info objects, we have again something called as special characteristics. First of all, we have seen info objects. It contains characteristics as well as key figures. See, this is how it goes. So in info objects, we have two types of info objects. One is characteristics info objects and the other one is key figure info objects. Key figure info objects. Your characteristic info objects contains descriptive information, whereas key figure info object contains quantitative information. And in characteristic information, info objects, again we have something called special characteristics. Special characteristics. Under special characteristics, we have three main areas. Under special characteristics, we have three main areas. One is time characteristics, and the next one is unit characteristics, and the third one is technical characteristics. These are the three things you can see here in this PPT. See, under special characteristics, we have time characteristics, unit characteristics, as well as technical characteristics. When I'm talking about time characteristics, it can be your fiscal period or calendar year. It can be a fiscal period or calendar year, day-to-day dates. This is about your time characteristics. When I'm talking about unit characteristics, for unit, it can be your local currency, different units, or units of measures, different units of measures. It depends on the different countries, because when you measure something, it will be with different measures. You can say it can be in kgs or it can be in liters. So different units of measures. That's what you see here. Time characteristics, fiscal period as well as calendar year. Whereas in unit characteristics, which comprises currencies and units of measures. It can be of local currency or it can be of different units of measure, that is sales quantities. And when we are talking about technical characteristics, again we have a request ID and change ID. We have a request ID and change ID. Request ID is nothing but every time when you try to load the data from source system, request will be generated, because during the loading process sometimes the loads may fail in between. So how do you identify that load? So we will identify that load by using this request ID, because before starting that load, before you extract the data, a request ID will be generated. So using that request ID, you will identify the load and then you will go for error analysis. And change ID is something which is related to business content, which we don't require in our case. In our case, we required characteristic info objects, key figure info objects, time, unit, as well as technical. So these, except change ID, we require everything for modeling part. Now moving to the next slide. Key figures. Here it talks about key figures. Key figures deliver the values that you want to report on. Of course, like we know that based on the key figures, you can make a different analysis. And these are of different types of amount, quantity, number, etc. And your SAP supports different types of currencies. Of course, like we will be seeing that in the lab session. So amount, quantity, key figures have either a fixed currency or units of measure or point to a unit characteristics. So we can use either a fixed currency or we can use a variable currency. When I'm talking about fixed currency, suppose if the client is using only USD, there is a fixed. Now if the client is along with dollars, say he is also using some pounds or he is also using some other currency, then it's a variable currency. So your SAP BW supports different types of currencies as well. Now going to the next slide. This is under modeling functions, this is the second area, that is source system. Because the first one is info objects. We have seen these info objects and what are the types of info objects. All these things we have seen. And under modeling functions, this is the second one, that is source systems. When we are talking about source system, in the previous slides we have seen SAP supports different kinds of sources. There is both non-SAP as well as SAP. The first modeling function is info objects and the next one is source systems. In source systems, SAP supports both non-SAP as well as SAP. Non-SAP source and SAP source. When I'm talking about non-SAP source, it can be your Oracle or DB2 or MS SQL Server. These are all non-SAP source. Even a flat file is a non-SAP source. And when I'm talking about SAP source, your SAP ECC is one of the SAP source. Okay. So under source systems, we have both SAP source as well as non-SAP source. But when we are working with modeling part, we will be seeing one non-SAP source and one SAP source. Means we will be seeing ECC as well as in non-SAP source, we can see a flat file. So this is about your source system. That's what it says. See here, all systems that provide SAP BW with data are described as source system. So these are the different source systems. SAP R3 system source, it can be your files, flat file sources, it can be your external systems or other BIW systems. So all these things will act as a source systems. And the second bullet point says the required data from the source system is provided to BIW. Can InfoCube be a source system? No, InfoCube is not a source system. InfoCube is nothing but your star schema model. Source system is something wherein we want to load the data from source. Okay, for example, it can be a database, or it can be a flat file, or it can also be an ECC system. That is a source. Okay, so InfoCube is not a source system, but for reporting purpose, you can use InfoCube. For reporting purpose, you can use InfoCube data, the data which is available in your InfoCube. But when you are loading data from source system, here we will be referring either ECC system or non-SAP source. Now going to the next point. So this is how your source systems will look like. Again, for source systems or for info objects, for everything we will be using administration workbench or data warehouse workbench. And the T code to go to this data warehouse workbench screen is the transaction code is RSA1. That is the transaction code. Using transaction code, we can do all the modeling part. Okay, so in today's session, we have seen what is an extended star schema and what are the landscape of SAP BW system. We have seen the data type, application type, as well as the presentation type. Then again, we have seen administration workbench, different tools of SAP BW system. We have two different tools. One is DWH workbench, which can be used for modeling as well as administration part. And the other one is Business Explorer, which is used for reporting part. Then we have seen the different components of this DWH workbench. We have seen components like modeling, monitoring, transportation, and all these things. Then in modeling, we have seen two different functions. One is info objects. Info object is nothing but it's a kind of business evaluation object. That's what we have seen, and it has two different types. One is characteristics and the other one is key figure info objects. Characteristic info object contains descriptive data, whereas your key figure info object contains a quantitative data. And again, in characteristics info objects, we have seen, let me come back to your question, Momita. In characteristic info objects, again, we have seen something called special characteristics. And the special characteristics, we have seen time characteristics, unit characteristics, as well as technical characteristics. Then the second modeling function we have seen is source systems. So your SAP BW system can use both SAP source as well as non-SAP source. When we are talking about SAP source, it's an ECC system, SAP ECC system. And we are talking about non-SAP system, it can be anything. It can be your relational database, or it can be your legacy systems, or it can even be a flat file. So these are the different source systems which your SAP BW supports. Can we create one target info cube from different source info cube? So you want to move data from source info cube to another info cube? In that case, yes, you can do that. So your question says, can we create one target info cube from different source info cube? See, in order to get the source info cube, first you need to load the data from any of the source systems. It can be from your non-SAP or SAP. Once that data is available in this info cube, say the source info cube, and this data, again it can be moved to another info cube. You can do that. We have discussed three areas. One is extended star schema. Other one is an introduction to SAP BW system. Then the administration workbench or data warehouse workbench. If you have any questions, you can.
All right, let's test your knowledge. Here's a question for you. Which SAP BO 4.2 tool is used for designing interactive dashboards with data visualizations? Option A, Crystal Reports. Option B, Analysis for Office. Option C, Dashboard Designer. Option D, Web Intelligence. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comments section. Hey there! Ready to dive into the world of SAP BO 4.2? Our course page is here to guide you through. In this course, you will master SAP BO 4.2. your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
So when we are talking about source systems, this is the remote desktop. Of course, you will be getting access to this remote desktop connection very soon. But for that, you need to check with the sales team. You can talk to Kavya for that regarding your remote desktop connection. Now click on connect. So you need to provide the username and password. Provide username, password. Then say yes, remote access. This is the remote desktop access. So what here we are trying to see is in a remote desktop access. So in a remote desktop access, these are the components we have. So this is your remote desktop. So in this remote desktop, what all we have? We have a source system which is already installed in your remote desktop, that is ECC system. Of course, we have a flat file by default, and we have a BW system inside this remote access, and also we have a, so in your remote desktop, these are the systems we have. We have SAP business objects, we have SAP BW system, we have SAP ECC as well as flat file. So all these things are available in your remote desktop connection. The moment you receive your remote desktop connection, you can see all these systems. See here, this is my remote desktop. So in my remote desktop, if at all I want to connect to my source system ECC, this is the user interface. So in order to connect to my source system ECC, what is the user interface? It is SAP GUI. This is the user interface in order to connect to ECC as well as to connect to your SAP BW system. So to access both ECC as well as BW system, we have the user interface SAP GUI. This is the user interface. And in order to access your flat file, we will have MS Excel already, which is already installed in your remote desktop connection. And to access your SAP business objects, of course, this is also installed. And in SAP business objects, we have different components. So in order to access different components, we have different user interface. If at all you want to access, say, a reporting tool in business objects, then we have a user interface called BI Launchpad. If at all you want to, say, create universes in business objects, again we have a different user interface called IDT, Information Design. So these are the different user interfaces. Using these user interfaces, you can access all these 4 systems which are available inside your remote desktop connection. Now, we were talking about source systems in SAP BW system. We were talking about the source system in SAP BW system. So the source system, in order to view the source system, where we need to go? We need to go to the BW system. Okay, SAP BW system. But for both SAP BW as well as SAP ECC, the user interface to access both these systems are your SAP GUI. So this is your SAP GUI. You'll have the shortcut on your desktop. If you don't have the shortcut, then you can go to Start, All Programs. Then you'll be having a folder name called SAP Frontend. So you can see here SAP Logon. So all you need to do is click on SAP Logon Pad. So in your SAP Logon Pad, you have ECC, that is the source system, and you have two BW systems. One BW is running on Oracle database and your other BW is running on in-memory, that is HANA database. So in order to check the source system, so we need to log into SAP BW on HANA, that is BW on Oracle. So double click on BW on Oracle. So you need to provide the username and password. These credentials will be provided to you. After providing your credentials, you need to, in SAP BW system or in SAP ECC system, you need to specify a transaction code in order to open each and every window, because a transaction code is something similar to the an identification of that particular screen. So most of the time, as I told you in my earlier sessions, RSA1 is the transaction code which we are going to use most of the time. So let me provide that transaction code, RSA1. Provide the transaction code in this box, then enter. So the moment you enter the transaction code, you can see here, data warehousing workbench modeling window has been opened for you. Now for source systems, so this is your navigator. On your left hand side, you can see the navigation box, wherein under modeling, you have different areas here. So in order to identify your source systems, this is your source systems. Click on the source systems. This is your navigator, and on your right hand side, whatever you see, this is your workspace. This is your workspace. The moment you click on source systems, on your right hand side, you can see the different types of source systems which are available for BW are displayed here. You can see the different types of source systems here. So you have SAP extractors as a source systems. Here there is of course a EC as a source system, that is ECC system. Again we have a flat file source system. This is a flat file. And of course there are different types of source system, but it's not installed. If you, for example, if you see the folder here, DB Connect. DB Connect, it is a source for databases. It can be any database. It can be your MS SQL or it can be your Oracle, anything. But as I told you, we are going to see two source systems. We are going to see two source systems. One is SAP source, that is ECC, this one, and the other one is non-SAP source, that is flat file. So these are the two source systems which we are going to see in our BW sessions. So this is how the source systems will look like. Going further, we have something called info source or data source. So when I'm talking about info source, your info source comes into picture here. So this is the SAP GUI. Then you have a data source or PSA. So this is where it comes between your source and your target system. That is your info source. And what is the purpose of info source here? See here it says it's a quantity of information logically belongs together and summarized into a single unit. To understand this info source, we have a pictorial representation here. See, you can see here. These are the two source systems which they have given in this slide. On your left hand side, you have R/3 OLTP system 1, and on the right hand side, OLTP system 2. Means both are ECC systems. So when you extract data from these two ECC sources to the target database, here the target is represented as info cubes. In BW server, you can see two info cubes here. Now a data source or info source is something from your source system, it goes to the data source, and from data source finally it reaches the target. So as per the diagram, see this is the data source, this is your source system. From your source system, it goes to the data source, and from data source it goes to the BW target. When I'm talking about BW target, it can be your info cube or it can be your DSO. It can be an info cube or it can also be a DSO when I'm talking about target. So your data source or info source is nothing but it's a quantity of information belongs together and summarized in a single unit. From that single unit, finally it reaches the target. And your info source contains what? Either transaction data or master data. So whatever the data you're loading here in this part, it can either be a transaction data, that is TD, or it can also be a master data. That's what the point says. Now going to the next slide. Of course, here we have something called extractors and all, how the data will be extracted into extracted from source system and then loaded into target system. Because when we are talking about BW system, it's like we are discussing about an ETL process. An ETL process is something where we will extract, transform, and then load the data into target system. Here in this slide, it's talking about how the data will be extracted from source system. Of course, at this point of time, we don't require this extract structures and all because internally everything will be done. The moment you execute internally, everything will be done. So at this point of time, we don't require extractors because we are more concentrating on SAP business objects rather than SAP BW system. But we just wanted to know how the data will be loaded from source to BW so that we can use a BW system for reports and even for BEX queries at later point of time. So we don't require this one. Similarly, after extract, then they're talking about transfer structure. Even at this point of time, we don't require any transfer structure. So finally, let us go to the transformations, because after extraction, the next thing comes into picture is transformation. When we are talking about transformation, before moving the data to the target system, the data will be transformed by using transformation rules. In SAP BW system, again we have something called transformation rules. So by applying these transformation rules based on the business requirement, we will transform the data which is coming from source, and finally after transformation, after applying transformation, we will load the data into SAP BW system. So that is about a transformation rules. So we have different rules in SAP BW system for transforming the data. See, here it says in this slide, transformation rules are used to determine how the transfer structure fields are to be assigned to the data source of info objects. So we will apply different transformation rules, and finally we'll move the data into data source and finally to the target. And we don't require this communication structure again because internally it will be communicated. Then finally it will be updated to the targets. When I'm talking about targets, you can see in this PPT there are two targets. One is info cube, which is on your right hand side, and the other one is ODS, operational data store. Now coming to the main area, data storage object. So we are going to discuss about data storage objects. So when we are talking about data storage objects, we have four different data storage objects. One is your persistent staging area. Other one is your DSO or ODS. ODS is in the older version, and in the newer version they are calling it as data store object, that is DSO. This is another kind of data storage. And the third one is an info cube. This is the primary target for SAP BW system. And the next one is master data. When we are talking about master data, we know that it contains three different tables: attributes, text, and hierarchies. So let us discuss about this data storage. First, we will see about persistent staging area. When I'm talking about persistent staging area, this is the one. the staging area between your source as well as the target, the central staging area for transactional data from different source systems. That's what you have seen in the diagram which I have drawn in the paint. So we have two different sources, one is ECC and the other one is flat file, and after source system your persistent staging area comes into picture, then your target system, that is BW system. So the first point says central staging area for transactional data from different sources. So wherein your PSA, the data will be the data will reside for a while temporarily in the PSA. Later on it will be moved to the target system. And the second bullet point says the data format remains unchanged, no summarization or transformation takes place. So in your PSA we won't transform any data. Whatever the format it's there in the source system, the same format is available in your PSA. And the third point says provides a suitable place for checking and changing data prior to updating the InfoCube or DSO. InfoCube and DSO are the targets. So your PSA provides it's a suitable place to check and change the data before updating it into the target system. So your PSA is the central staging area wherein this place is suitable for checking and changing data before updating into the target systems. And the last point it says data from PSA can be uploaded into DSO, InfoCube or both. So whatever the data you have in this PSA, this data can be uploaded into InfoCube, DSO or both. That is what the last bullet point says. This is about your PSA. Now what is the advantage of PSA? See here it says the advantage, it cleanse, modify data before uploading into the respective targets. Okay, so before uploading the data from PSA to different targets, you can even modify or you can cleanse the data before doing this. This is the advantage of PSA. So always in your ETL process, the data from source, it goes to PSA, and from PSA finally it goes to the respective target systems. Now going to the next slide. It's talking about ODS or DSO, okay, operational data source. At the bottom you can see the different source systems. So from source systems, the data goes to the staging engine. You can see above your source system, you can see there is a staging engine here. Okay, it goes to the staging engine, and from staging engine, it goes to the operational data store or DSO. So it will be something like this. So this is the source. When master data, then when master data gets transferred. So usually the first load will be your master data load. Always the first load will be your master data load. Later on, the transaction data load comes into picture. Okay, so this is the source, same source. We have two, that is ECC as well as flat file. From ECC to flat file, then say we have a PSA. Then after PSA, let us say we have a DSO or ODS, then InfoCube. Then InfoCube. So as per this diagram, from source, it goes to staging area, from staging area, ODS or DSO, then to InfoCube. To PSA, this is the PSA. Then this is your DSO or ODS. From PSA it goes to DSO, and finally from DSO it goes to the InfoCube. Here I am talking about the transaction data. I am not talking about the master data. If you can recollect the diagram of your BW extended start schema, whenever I'm talking about transaction data, you can think about the dimension tables and the fact table. If I'm talking about master data, the master data scenario is different. Say suppose you have a source here. Let me say this is a flat file. For master data, we have three different tables. We have attribute table, text table, and hierarchy table. This is for master data. This is for master data. Okay, only for transaction data, the data first goes to ODS or DSO. After that, finally it reaches the target. That's what you can see in this diagram. See here you have a source system, then you have a staging engine. From staging engine, operational data store. From operational data store, info cube. Okay, so this is about your DSO. The first we were discussing about DSO here or ODS. This is how the architecture of ODS shows, the part of ODS shows in the BW architecture. Now going to the next slide, we can see different points about data store object. So what is your DSO? A data store object acts as a storage location for consolidated and cleaned up transaction data. That's what we have seen in the earlier session. Your DSO or ODS contains a detailed data. So here, this DSO, it contains a detailed level of data. That's what the first point says here. Acts as a storage location for consolidated and cleaned up transaction data. And the second bullet point says it's a permanent store for data from different data sources. So you can use different data sources, but whatever the data you're storing in DSO, it's a permanent data. You can even write queries on top of this DSO, the data which is available in DSO. You can even create reports on top of this DSO target. That's what the third point says. Source of data for reports. So even you can use your DSO as the source of reports. Say this is your reporting tool. Say business objects. This is your reporting tool. So if at all you want to create reports on top of DSO, then in between you will have a Bex query. Using Bex query, you can access the data which is available in your DSO. Using your Bex query. So that is what the third bullet point says, source of data for reports. So not only from business objects, even there is an internal reporting tool in SAP BW, that is Business Explorer. Using Business Explorer also, you can create reports on top of your DSO. And when we are talking about DSO, the next slide says every DSO or every ODS object is represented on the database by three transparent tables. So your DSO structure, your DSO is nothing but it's a kind of table. You can say it's a table. Every DSO object is represented on the database by three transparent tables. These are the three transparent tables: active data, new data, change log. Of course, we are going to discuss these three tables when we see the lab session for ODS or DSO. I guess Bex can be used for both info cubes and DSO, right? Yes, we can use Bex reporting tool both for info cube as well as DSO. That's right. And here in this slide, when we are talking about this slide, it says it contains your DSO represented on the database by three transparent tables, that is, which is rich client. Rich client is one of the reporting tool in business objects. We are going to discuss that when we talk about the components of BO. As of now, like we were talking about one of the target in SAP BW system, that is ODS or DSO. So it has three tables: active, new, as well as change log. So in this diagram, when I'm talking about DSO, it is represented by using three tables. Active data table, new data table, change log. So your DSO is represented in three ways. We are going to discuss about these three things when we see the lab session for DSO. When we load the data from either ECC or flat file into DSO, we are going to discuss these 3 points: active data, new data, as well as change log. So this is about your DSO. Then the advantages are, here in this slide it says your DSO contains the most granular data, most detailed information. That's what the slide says. And the advantage of DSO is, so of course here it's showing you the three different tables. One is active data table, other one is new data or modified, and the third one is change log. We are going to discuss these things when we see the lab session for DSO, because we are going to see how to load data into DSO and how to load data into InfoCube and how to load data into master data table. These are the three lab sessions we are going to see for SAP BW system. And later on, how to create queries on top of InfoCube as well as DSO by using BEX. Whatever the queries we have created by using Business Explorer, these queries we are going to use in our business objects reporting tool. So the benefits of ODS is, it's a suitable place for granular data prior to updating the InfoCube. Okay, so that's what you can see in this diagram. From DSO, finally the data has been updated into InfoCube. So that's what the slide says, suitable place for granular data before updating to the InfoCube. And the second option, it says support InfoCube changes without having to reload data from source system. So suppose if at all, this is my InfoCube actually. If at all I wanted to reload the data into this InfoCube. So instead of again loading the data from ECC to PSA, PSA to DSO, and from InfoCube, reloading the data into InfoCube, already the data is available in DSO, because whatever the data you have here in this DSO, this data I have loaded from ECC via PSA. So what you can do is directly you can upload this data from DSO into InfoCube. That is what the second advantage it says, supports InfoCube changes without having to reload data from source system. So whatever the changes you required, directly make the changes from DSO. Again, no need to go from load the data from source, PSA, DSO, and from InfoCube. It's again a long process. So that is what the second advantage of DSO. So we have seen PSA. We were discussed about DSO, and the next one is InfoCube. So InfoCube is a primary target for SAP BW system. See the benefits of DSO. It's a suitable place for granular data before updating to the InfoCube. So when I'm talking about granular data, it's nothing but the most refined data or the detail level of data. So your DSO contains the detail level of data, and you can update the data from DSO to InfoCube. That is what the first bullet point says. When I'm talking about the second bullet point says, it support InfoCube changes without having to reload data from source systems. When we are talking about this one, if at all there are some corrections which I need to do in InfoCube, I can do it from DSO. I can make the changes from DSO to InfoCube. I can make the changes in InfoCube, and later on I can move the data from DSO to InfoCube instead of bringing the data again from my source to PSA, then PSA to DSO, then finally to the InfoCube. That is what the second bullet point says. Support InfoCube changes without having to reload data from source systems. Next slide, we are going to see about the primary target, that is InfoCube. InfoCube is the main target for SAP BW system, wherein all the summarized information will be stored in your InfoCube. The reason your BW system contains two targets, one is InfoCube and the other one is ODS or DSO, is your DSO or ODS contains a detailed level of information or a granular data, whereas your InfoCube contains a summarized data. Because the purpose of the data warehouse is, it doesn't mean you need to load each and every transaction which has occurred. The purpose of data warehouse, say suppose today, for example, there are 1,000 transactions has taken place in OLTP system. It doesn't mean you need to load all these 1,000 transactions into your data warehouse system. That is the reason. 1 minute, Momita, I'll come back to your question. Let me explain this. So that is the reason your InfoCube contains a summarized information. So whatever the data you feel, whatever the data the analyst feel that is important for analyzing the things, that data you can load it into InfoCube. And the remaining data, the detailed level of each and every transaction, can be maintained in your ODS. So this is where you can create transformations. That is between your PSA and DSO. And also you can create transformation between DSO and InfoCube as well, if you want. Okay? Because these are two different targets. One is DSO and the other one is InfoCube. You can create a transformation between PSA and DSO. Still, if you required, if at all you wanted transformation between these two targets, that is DSO and InfoCube, again you can create a transformation between these two, InfoCube and DSO. Now going back to the slide of InfoCube, so you can see the InfoCube here above your ODS in this architecture. Now, the first bullet point says the primary source of data for queries and reports. So your InfoCube is the primary source of data for queries and reports. So whenever we are talking about BEX queries in our SAP Business Objects reporting tool, it's like we were talking the BEX queries which are created on top of InfoCube. Okay, most of the time, whatever the BEX queries, whatever the BEX queries which we are going to access from Business Objects reporting tool, these BEX queries are created on top of InfoCube. And very few BEX queries we will be seeing on top of DSOs. So that is the reason the first bullet point says the InfoCube is the primary source of data for queries and reports. See here, this is how it will be. So one is your InfoCube and the other one is, say, DSO. This is your InfoCube. And the next one, say, this is another target, DSO. And there is a reporting tool called Business Explorer. In SAP Business Warehouse itself, there is an internal reporting tool, Business Explorer, or BEX, we call it in short form. And again, we were learning about a reporting tool called, say, SAP Business Objects. Now, if at all I want to create a BEX query on top of my InfoCube, the primary source of data to BEX query will be your InfoCube. This will be the primary source for the BEX queries. And the secondary will be the DSO. First one will be the info cube and the next one will be the DSO. And whatever the BEX queries you create here, whatever the BEX queries you create here, this BEX queries can be accessed from your business objects reporting tool. Okay, these BEX queries can be accessed from your BO reporting tool, and the data for these BEX queries are either from your info cube or from DSO. Because in business objects, when we want to create reports, we have different data sources. Either you can connect to a data source called universe, or you can connect to a data source called BEX queries, or you can even connect to a data source called SAP HANA. Okay, so there are different data sources wherein you can connect to your reporting tool by using business objects. So if at all I want to connect to the data which is available in my BW system, so this entire thing is your BW system. Okay, if at all I want to create reports in my business objects by using the data of SAP BW system, then via BEX queries, you will be accessing the data which is inside your cube or DSO. So that is the reason the first bullet point says it is the primary, see what it says, the primary source of data for queries and reports, your info cube. The next one, your info cube is based on extended star schema design. We know extended star schema because we have already discussed about this extended star schema. So whatever the info cube you are designing in your SAP BW system, that info cube is based on your extended star schema design model. So we are going to design an info cube in a BW system. So in the very next session, we are going to see that. There are different types of info cubes. We have a basic cube, there is a multi-cube, and there is also a remote cube. But in our lab sessions, whatever the info cube which we are going to design is, it is a basic cube. And like this basic cube, you can create number of other cubes. That is nothing but your multi-cube. But we won't be working with a remote cube. Okay, remote cube, again, it's a different concept wherein people who are working with SAP BW system, they can concentrate on this remote cube. But in our case, we are going to see how to create a basic cube by using SAP BW module. So these are the steps involved in order to create an info cube. Of course, all these steps we are going to see in the lab session. So these are the steps involved in creating info cube. So this is how your info cube will look like. So this info cube has 3 dimensions. You can see the time dimension, customer dimension, as well as material dimension. So each and every dimension table we will create in a BW system. For example, if at all we want to design a customer dimension table, prior to that customer dimension table, we need to make sure we have all the attribute information for that customer dimension table. And if at all we want to design a material dimension, again we need to make sure we have all the attributes related to material dimension. That is how we were going to create different dimension tables in our info cube. And if you can remember, as I told you in my previous session, a minimum of 4 dimensions can be created for one info cube. That is time, unit, data package, and one custom dimension. And the maximum dimensions can be created for one info cube is 16. It is 16 dimension tables can be created for one info cube. That's what I have explained to you in the previous session, the dimension tables. This is how your info cube look like. If at all you want to see the info cube in your remote desktop, go back to your remote desktop. To access the remote cube, to access the info cube in your modeling window, you need to go to modeling, info provider. Of course, we have not created any info cube. I'll try to show the info cube which is already created by some other participants. Okay, so this is the info area. Usually we call it as info area is nothing but wherein you can store all the different attribute information, different objects, different components, everything you can store in your info area. So this is the info cube. You can see the symbol here, delivery person. For example, if I expand this info cube, I can see the flow, what all they have created. And if I double click on this info cube, you can see the info cube structure, how it looks like. Okay, so this is the info cube. The name of this info cube they have given as delivery person. And what are the dimensions they have? See, these are the three default dimensions. One is a data package, time, unit. And the other one is a custom dimension. You can also rename this custom dimension. You can rename this custom dimension as well. See, your info cube, your dimension tables, and key figures. When I'm talking about key figures, this is nothing but your fact table in your extended star schema model. In your extended star schema model, what all you have a dimension table as well as a fact table. So all your key figures or all your business measures are stored in this key figures folder. So this is how we are going to create an info cube in BW system. Of course, this one we have not created, but I'll show you how to create this info cube by using this data warehouse workbench modeling window. So this is how your info cube will look like. Now going to the next slide. As I told you, like it is based on your extended star schema model. You have a fact table and all the dimension tables connected to the fact table. And the next data store area is, we have already seen the three data storage areas. One is PSA, wherein the data will be reside in the PSA temporarily before loading it to the respective targets. And the next one is DSO, that is another kind of data storage area, and it's a permanent data storage area where you can store the data permanently and you can also perform reports and queries on top of your DSO. And the third data storage area we have seen is an info cube. That is one of the primary target of SAP BW system, which is based on BW extended star schema model. And the fourth data storage area is your master data. When we are talking about master data, you have already have some information on this. It consists of three different tables, attributes, hierarchies, and text. And the main aim of master data is, see here it says in the second bullet point, aim is to provide info cube independent. So your info cube will operate independently, whereas your master data, all the master data loads will be done separately. So the first load we are going to see is a master data load. So directly we will load the data from source into these three tables, attributes, hierarchies, and text. Then we will start loading the transaction data load, which is into info cube. And this is how your master data tables will look like. Of course, like we are going to again see this flow as well, master data flow. Comparison between, this slide talks about the comparison between PSA, ODS as well as info cube. Later on you can go through this slide, the comparison of, because all the three are data storage areas. Even PSA will store data temporarily, ODS will store data permanently, but it is a detailed data. Info cube also will store data permanently. Now the next one they're talking about the reporting part. So this is how the reporting part comes into picture. You can see in this slide, you can see a source system, that is SAP R/3 is the source system. Then you will extract the data from this source system, transform it, and finally load the data into SAP BW system, which you can see on your right hand side in the form of cube. Then on top of your cube, you do the analysis by using the reporting component called called Business Explorer. Okay. So to understand this, we have a reporting tool called internal reporting tool in BW called as Business Explorer. You can see here. If at all you want to access Business Explorer, again there is a two different user interfaces we have in order to access Business Explorer. One is directly from your SAP GUI, you can access your business objects. Sorry, you can access your BEX reporting tool by using the T code. That is one method in order to access Business Explorer. And the next one is you can go to Start All Programs. Then you can see a folder called Business Explorer. You can click on this folder. It is Business Explorer. Again, there are different components. We have Analyzer, there is a Query Designer, Report Designer, as well as Web Application Designer. Okay, when we are talking about Query Designer, this is where we will create all our queries in Business Explorer. So in Business Explorer reporting tool, all the queries are created by using Query Designer. And when I'm talking about Analyzer, all the reporting part, like usually your BEX Business Explorer reporting tool, it almost looks like an Excel reporting. So if you're using Analyzer, we will be creating reports and we will be analyzing the things by using Analyzer components. Then we have a Report Designer. It is a kind of, again, a dashboard kind of thing where we will create reports, and we can even create a simple dashboards by using a Report Designer. And when we are talking about Web Application Designer, your Web Application Designer is similar to your, we have a dashboard in SAP Business Objects. This one dashboard recently they have introduced. Of course, I couldn't able to recollect the name. So it's similar to your dashboard designing tool. So your Web Application Designer is similar to your dashboard designing tool. A very good interactive dashboards can be designed by using Web Application Designer. Yeah, this is in Business Objects. You can call it as a report. This one kind of designer. Of course, I don't recollect right now, but I'll be telling you this. So these are the different components which are available in your Business Explorer. So let me show you a Query Designer. This is one area wherein you can connect to your target, that is InfoCube or DSO, in order to create queries. So all you need to do is you need to select your BW system. As I told you, we are going to use BW on HANA. So you need to select the BW system from your SAP logon pad. Click OK, and you need to provide the parameters. One is client. Client is always 001 for your SAP BW system. If at all you want to know the client information, you can see here. So this is BW on Oracle. So you can see here 001. So the same information you need to provide here. Client is 001. And username, password, it is your username and password. Whatever the username and password the admin provides to you, it is the same username and password. The language, by default, it is English. Then you can click OK. So we are trying to open the we are trying to open the Business Explorer. It's one of the reporting tools. So you can see Business Explorer, Query Designer. This is an internal reporting tool which comes with SAP BW system. So this is how your BEX Query Designer will look like. Your BEX Query Designer is similar to your Query Designer in your SAP Business Objects. In SAP Business Objects, if at all you want to write query on top of your InfoCube, you need to open a Query Designer by using BA Launchpad. There we'll call it as a Query Designer. Here it is a BEX Query Designer. But in order to access your target system, that is InfoCube or DSO, you need to make sure the target system is available, that info cube is created or your DSO is created. Then only we can create queries on top of them. Of course, like as of now, we have not created anything. So usually this is how they do. Go to query new. In order to create any new query, you need to make sure there is an info cube or DSO is available. But all your info cubes and DSOs are available inside this folder called info areas. As I told you, info area is a place where you'll try to store all your components. So these are the different folders you can see under your info area. I have shown you the info cube called salesperson. So let me try to connect to that salesperson. So select your salesperson folder, then open. So this is the one. This is the info area which we have seen. Sorry, this is the info cube which I have shown you. Delivery person. So this is how you'll select the info cube and you'll say open. The moment you say open, on your left hand side, it will display all the dimension tables as well as what are the key figures they have created for this info cube. So this is how usually we will access the info cube by using BEX Query Designer. This slide talks about the same reporting tool. This is the BEX Query Designer. Whatever you see here, of course, this is not a query designer, rather it is a BEX analyzer. I told you in analyzer, we are going to create reports, but in query designer, we are going to create queries. So this is how usually we are going to create a report. If you notice here in this slide, in the bottom you can see an info cube. So whatever the data is stored in info cube, it will be stored in your star schema model, that is contains dimension tables and fact table. Now in the application server, you can see OLAP processor operates on this info cube. And finally, you'll create a query on top of this info cube, and the report for the query can be generated by using Excel workbook. So when I'm talking about BEX analyzer, all the reports in your BW, it looks like an Excel workbook reports. So finally, the report will be presented in the presentation layer. This is how the reporting part will be done in SAP BW system. So in BW, so what are we going to see in BW? So you have an info cube, then DSO, Business Explorer. Then we are going to see two sources, so that is ECC as well as flat file. These are the two sources which we are going to see. So from this ECC and flat file, we are going to load the data via PSA. This is the staging area. ECC to PSA, then to DSO, and from DSO to info cube. Then whatever the data is available in your info cube, by opening Business Explorer reporting tool, we will create queries on top of info cube. And these are the components of Business Explorer. We are going to see two components. One is BEX Query Designer and the other one is BEX Analyzer.
Hey there! Ready to dive into the world of SAP BO I 4.2? Our course page is here to guide you through. In this course, you will master SAP BO I 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO I 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.
Now T code RSA1. This is the most frequently used C code, RSA1, yeah, I think so many of you might have created some info areas. I can see this is the one which I have created. Then we have info area for MDA. Okay, customer master data attribute. Fine, good. So this is the source. From source, we usually what we do, we have loaded data into some target. Say you have loaded the data into InfoCube target. And the same data, whatever the data you have in the source system, same data, say you have loaded into two different InfoCubes. Okay, the first cube, let me say it's actual InfoCube, actual data, and the second InfoCube, I'll call it as planned data. The second InfoCube contains planned data. So this is your source. So from your source, what you can do is, you can load the data into two different InfoCubes. One InfoCube contains the actual data and the other InfoCube contains the planned data. A multi-provider is something wherein you can combine these two InfoCubes into a single provider. That single provider, we call it as a multi-provider. On top of this multi-provider, you will have small symbol to identify the multi-provider. So this will be your multi-provider. So your multi-provider is something wherein it combines two different targets. It can be both can be your InfoCubes, or it can be one can be your DSO and other can be your InfoCube. Okay, so it combines together and it will give you the output. So output again, from BEX, you'll get the output. Using BEX, you'll get the output. Business Explorer. Okay, this is your multi-provider. Even if we can create BEX queries on top of multi-provider. Of course, we can by default create BEX queries on top of InfoCubes, DSOs, and apart from these two, we can also create queries on top of multi-provider. Multi-provider is nothing but it combines two different cubes and it will give you the output. But in order to create this multi-provider, first of all, we need to make sure a data has been loaded into two different cubes, InfoCubes. So as of now, like we don't have any InfoCube because the first load we have done is a master data load. If you have loaded, I thought you guys have loaded some data into InfoCube, so that I thought of using the same InfoCube. Actual data contains the transactions which has taken place, the real transactions which has taken place. And planned data is something which they might have planned, okay, this is how, for example, for the month of June, this is how we are expecting the sales figures. So these are the figures we are expecting for the month of June. So that is something planned, but actually something which has been taken place. The transaction has been taken place. That is the difference between actual and planned. So they want to compare, okay, actual with the planned data. So we have planned something like this for the month of June, but this is how we could able to do. Okay, that is the difference between actual and planned. So let us create a multi-provider, but in order to create multi-provider, first we need to make sure uh, we must load data into two different info cubes, and your multi-provider uses union operators in order to combine these two cubes. So it uses union operator. So when I'm talking about union operator, so most of the columns should match. So almost you must have the same columns. That is the reason if you take the source, in your source, whatever the columns you have in the source, the same columns you'll have in InfoCube 1 as well as InfoCube 2. But the data will change because actual data will be different and the planned data will be different. So your multi-provider uses union operator in order to combine both the cubes. Once we are done with the multi-providers, that is where we'll start up with the Business Explorer. I'll show you how to connect to different targets using Business Explorer and then to create reports. So these are the things which we are going to learn in BW sessions. Later on, once these things are done, we will be going back to the business object. That is what we want to concentrate more. This is actually all these things are, majority of these things are for BW guys. Again, there's a question. Have made two info provider with InfoCube. Okay, you mean to say like you have created two info providers with InfoCube? So can you be more specific on your question? Yes. Okay. See, don't create two info providers. Okay, have made two info providers. See, your InfoCube 1. Okay, what is your question actually?
I mean to say that there are two info providers where the target is InfoCube. You can use that. I wanted to say, not a question.
So yeah, for two info providers, you can combine into a single multi-provider. Is that?
No, there is no question. You were talking that whether we have created any info provider with InfoCube.
Mm-hmm.
So yeah, I made two info providers with where InfoCube is the target.
Okay. What is the?
There is no question.
Okay, there is no question. Okay, fine. That's fine. Okay, let us create two info cubes and load the data into cubes. Then we'll create multi-provider on top of that. So I'm in the modeling screen, DWH Workbench modeling screen. I'll use the same info area. I'm not going to create a new one. This is the info area which I have created. This is the info area for MDA. So first let me create the source table, source system for the multi-provider. Here I am taking two key figures. One is a sales price and the other one is quantity. Insert some sample data. So this is the source file. Now save this file in .csv format. I'm creating this file for multi-providers, so I'll name it as mp_material. Okay, this is the source file. Now we want to load this data into two different cubes. I'm using the same info area. I'm not creating a different one. This is the info area which I have created. So first we need to create characteristics and key figure catalogs. Already I have a characteristic catalog. Okay. In the same characteristic catalog, let me create the other characteristics. So first one is material ID. Data type, NUMC, and say length is 10. Validate and activate. See, whatever the characteristics I'm creating here, these characteristics are for multi-providers, are for info cubes. I want to use them for info cubes. But whatever the characteristics you already have, the customer ID, name and address, these are the characteristics of master data. So we don't want to use this, but I want to use the same characteristic catalog. So material ID, then the next one is description. Character, data type length is 15. Activate. So you can ignore the warnings and you can activate. The next one is material ID, description, then brand, data type, CHAR, length, say 20, check and activate. Then the next one is color. Material color, data type CHAR, length say 20, check and activate. These are the characteristics. And I have included two key figures. So all your key figures has to be created inside your key figure catalog. But here we don't have a key figure catalog. So what we can do is we can create key figure catalog. Right click on info area, create info object catalog, and I'll name it as key figure catalog. Object type, key figure, create, check and activate. So the two key figures you can create here. So right click on your key figure catalog, create info object. First one is selling price. See, the selling price, data type for selling price is amount. So for amount, you know what is the option you need to give. So under unit/currency, you must give 0 currency. This is for selling price. Check and activate. Now we have one more key figure, that is quantity. For quantity, what you need to do is right click on key figure catalog, create info object, I'll say material quantity. See, for quantity, the data type is this one. You can see under type / data type. For quantity, you need to select this one. And if it's a fixed unit of measure, say for example, the quantity is in liters or it's in kgs. So if, like that, if it's a fixed unit of measure, then directly you can mention here. Else, the same way, like how we have given for amount. For amount, we have given 0 currency. For quantity, you must give 0 unit. Now check and activate. For amount, it is 0 currency. For quantity, it is 0 unit. Check, activate. See, now we have created all the characteristics as well as key figures. And the next step, what we need to do, we must create an application component. But do we have application component? Yes, we have already created application component for master data attribute. You can use the same application component. So go to modeling and data sources. This is the application component we have created, but we have given the name as master data attribute, but we want to use the same application component. So right click on your application component, create data source. So here we are not going to create another application, rather we want to use the same application component. But we want to create a different data source for transaction data, because whatever the data source you have here, this data source we have created for master data attribute. But now we want to create a data source for transaction data, but we will be using the same application component. So right click on your application component, create data source. So my name is data source underscore multi-provider, MP, multi-provider. Data source type, transaction data, click on continue. The same way you need to provide the general info. We need to provide the short, medium and long description. Data source for multi-provider. Now go to extraction tab, file name, browse your source file. So all these steps you know, browse the source file. Header rows to be ignored is 1, data format, separated with separator, data separator is comma. Then go to proposal tab, click on the button, load example data. So it's trying to access the source file, allow. This is the data which we have inserted in the source file. Now go to fields tab, copy paste all the technical names for your multi-provider source. For that, go to modeling, info objects. So these are the technical names. So first one is what? Material ID. The technical name is MATL ID. Control C, paste. Control V. Description, copy, paste. Color. Do it for all the objects. And these two are the key figures. One is sales price. So after pasting all the technical names, now enter. You can press enter from your keyboard. So default from info objects, this dialog box opens. Click on copy. See here we will get two additional columns, and these two additional columns refers to sales price as well as quantity. Let me show you that. See here. The first one is information box. In this information box, what it says, reference field currency added automatically. So this reference field currency is for your sales price. So continue. And again, you can see another pop-up which says reference field unit added automatically. This reference field unit is for quantity. Continue. Okay. So now you need to keep all the fields in an order. Make sure all the fields are in an order. For that, so you have material ID, description, color, brand. Now selling price. After selling price, it should be quantity. You can select the entire field and move up. Okay. See, now you have all the fields in an order: material ID, description, color, brand, selling price, quantity, and this currency. This is the reference for selling price, and unit is the reference for quantity. So after arranging the order for all the fields, now go to preview, read preview data. Before it reads the preview data, it will prompt you to activate. External. Okay, fine. You can continue with the warnings. Okay, this is how your output will look like. Of course, we need to rectify this quantity. So it will be in the fields tab only. In the fields tab, of course, it's already activated. Okay. Later on, again, I'll show you this. So now we have created a data source. After creating data source, usually what we do, the next step, we will create a target, that is either InfoCube or DSO. But in this case, we want to create two InfoCubes. For that, go to modeling, info provider. This is the info area which I am using. Right click on info area, create InfoCube. So the first InfoCube name I'll describe as IC underscore InfoCube underscore actual. So this InfoCube, the first one I've named it as InfoCube actual. Click on create. Now these are the default dimensions: data package, time unit, and dimension 1. Only dimension 1 is customized. We know this. So we want to move all the characteristic info objects into dimension 1. So what you can do is click on the icon, info object catalog. This dialog box opens. Double click on your characteristic catalog. Expand characteristics folder. Select all your characteristic info objects. Drag and drop into dimension 1. And you can rename this dimension 1. Right click on it, properties. I've renamed it as material dimension. Now key figures. This time double click on key figure catalog. Expand key figures folder. Select all your key figures. Drop into key figures folder, which is inside your InfoCube. Now activate. Check and activate. So this is one InfoCube. Now we want to create another InfoCube. Right click, create InfoCube. provide technical name, long description, then create. See, technical name, if it exceeds more than 0 to 8 characters, sometimes it will give you this information. So what you can do is, okay, this is a different InfoCube. This is the second InfoCube. InfoCube planned. Now, move all the characteristics into dimension 1. Double click on characteristic catalog, expand characteristic folder, the same way how I did earlier. Drag and drop all these characteristic info objects into dimension 1. Now key figures, double click on key figure catalog, expand key figures folder, select your key figures, drop into key figures inside InfoCube 2. Now check and activate. So now we have two InfoCubes. One is actual and the other one is plan. After creating InfoCube, what we do usually, we will go for the transformation. We will do the transformation part. So to do that, go to modeling, data sources. This is the data source which we want to use for multi-provider. Right click on this data source, create transformation, object type, InfoCube, technical name, provide InfoCube, technical name, then continue. Okay, this is the transformation between data source and InfoCube 1. This is InfoCube 1. Now activate, check and activate. This is the transformation.
Alright, let's test your knowledge. Here's a question for you. What is the main function of the Central Management Console, CMC, in SAP BO 4.2? Option A, to create and manage universes. Option B, to schedule and distribute reports. Option C, to design interactive dashboards. Option D, to explore and analyze data. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Ready to dive into the world of SAP BO 4.2? Our course page is here to guide you through. In this course, you will master SAP BO 4.2, your go-to tool for managing business operations. It's like having a magic box for sorting out supplies and getting them where they need to go. We cover everything you need, from the basics to the fancy tricks, crafted by experts who know their stuff. Your teachers? They are seasoned pros, here to support you every step of the way. And guess what? Our students love it too. Real folks just like you have found this course super useful. Best part? It's budget friendly. Learning doesn't have to cost an arm and a leg. Ready to level up your SAP BO 4.2 skills? Sign up now. For more details, hop over to ZaranTech's website.